Hello friends, hope you are having a fantastic day today. So now we are going to do an entire course on the string data structures. They are one of the most popular kind of interview questions and we are going to learn everything there is to know about strings. On top of it, we will learn 15 most task, most like and most important lead code problems from the string data type. And my expectation is that by the end of this course, you should become a complete pro in all sorts of string related questions. So without any delay, let's get started. Strings are one of the most unique and most versatile kind of a data structure that we can call. And the funny thing is, if you see the broader categorization of all the different data structures, you would not find string in any one of these particular patterns. String is actually unique in a nature because it is the combination of all the characters put together and that forms any particular string. Because characters on their own are pretty mundane because you cannot do much of the task. For most of the things that we usually do in the real world, we need to deal with different words, different characters, different serial ID, different numbers, different phone numbers, all sorts of bunch of different items. And for that we use character as the underlying implementation, but only character using is not going to be sufficient, and for that we need to use a way to store the combination of different characters, and that's where the majority of string application comes into place. Strings are defined in all the different popular languages. They have vast amount of uses, like you can use string for word processing, for HTML, for artificial intelligence, machine learning, data storage, storing the encryption certificate, storing the first name and last name of person. So all sorts of things can be done using different forms of strings. But the thing is, in terms of the perspective for DSA problems and DSA algorithms, we need to understand that how to perform different operations on strings, what are the different ways we can do it, and what are going to be the common scenarios. Because remember, you are always going to encounter where you are using string as programmatically, or in your interviews, or in real world application. So now let's talk about some of the basic operations that we usually follow and that we are going to learn more about in all sorts of 15 lead code problems. So one of the most common things that you can do with the string is the creation and destruction of the string. So if you want to create a string, basically how it works is that in the memory of the computer, we are given a continuous block of memory is provided where you can store any particular characters. Now these characters can have multiple meanings. You can store simple values like A to Z characters. You can store some special characters like percentage, plus, minus, these kinds of operator signs. You can also treat numbers as different characters as well, and many times they are also being stored inside the string, or it could be combination of every single one of those. And that's why you have these strings that contains all of this jumbled information in a particular format that computer can understand and humans can read, and then we will have to do multiple different operations. So first operation, that where we are creating a string, can be typically done in big of n time, because we don't know how many number of characters are going to be there, and initially we just start with one character, and if we need more space we will assign two characters. If we need more space, we will copy all the contents into four characters, and so on and so forth. This is going to be the most basic type of implementation, but lucky for us, most of the problems are not required for us to do that, and they are typically handled by the language of our choice, be it Python, Java, .NET, C Sharp, whatever it can be. Next thing is, because strings are the combination of multiple different characters, so we need some way for us to identify or fetch each of the character. So fetching individual characters can be done in big of one time. Let me give you an example. Let's say I create a string and I put down the value as parth. Now I say that what is the character present on the first index position or the second position inside this given string, then it can immediately return value a in constant time, because this is a continuous block of memory, so it is very fast for us to store or retrieve values from any particular cell. Next common operation that you can see is the length of the string, and once again the length of the string can also be done in big of one time. Now next operation is concatenation. Concatenation means that if we are given string 1 s1 and string s2, then if we are combining these two strings to create a new string s, let's say s3, that is going to be combination of s1 plus s2 in some form, then this process is called concatenation. And this can be done in big O of m plus n time, where m is going to be the length of s1 and n is going to be the length of s2. Same way, opposite of concatenation is substring. And in order to create a substring, basically, let's say if we are given a string that contains 10 different entries or 5 different entries, and we only want a certain portion of this size, so this process is called creating a substring out of the given original string, and this can be done in big O of k time, where k is the total length of any substring that you are trying to create. Same way, we can split an existing substring, and this splitting is typically done in big O of n time, because overall the total number of characters remains the same. Finding any particular character can be also done in big O of n time as well, because we need to iterate over every single value in order to make sure that whether that character exists or not. So these are some of the common operations that we usually do with strings. There are some more advanced operations as well, that is pattern matching and understanding or finding the meaning from any particular given string, and there are a lot of different algorithms, and all of these things would be discussed in the 15 most popular LeetCode problems that we are going to solve. And I can guarantee you, after completing these questions, you will be able to solve all kinds of string questions, that's for sure. So now, without any delay, let's get started with the meat of our course, and that is the 15 LeetCode problems. So the LeetCode problem we are going to solve is called longest common prefix, and you can see that this is a LeetCode easy problem and also a very well-liked problem on LeetCode. Now the problem statement is very simple. We simply need to write a function to find the longest common prefix of string amongst an array of strings that we are given as the input. And if we cannot find any prefix, we need to return an empty string. So let's try to understand this with a couple of examples. So in this case, what is the common prefix that we are able to find that is common for all the 4 strings that is currently given? The answer is quite simple. FL is the common entity or common prefix that we can find. So in this case, we will return FL as the answer. Now let's take another example. So in this case, what should be the answer? Well, first, it seems like this RA is going to be the answer, but RA is not present in this string. So in this case, since we cannot find any common prefix, so we need to return an empty string as the answer. Now to solve this problem, we are going to use a very simple logic. Input we are given, we are going to treat as if the string 1 that is currently present, this is the longest prefix that can be possible, because any other values, they have to have all the characters that are present in the string 1. How can it happen? Let's assume that in the example, currently the substring 1 is the value like xyz, something like this. Now, even if all the other values like xyz, a, b, c, something like that, and then xyz, and then all the long values, still the longest common prefix has to be the first substring as its whole. So it can never be longer than the first string inside the given array. That is a given fact. So using this logic, we will try to treat that what if the first string is the longest common substring, and by treating this, we will try to compare this string with all the remaining strings that are currently present inside the array, and that's how we will be able to reach to the solution. So let's try to understand the approach that I'm suggesting. Suppose this is the input we are given. So now, based on our approach, we will try to see that, let's assume that this is the longest current prefix that we have. So we create a variable and we are going to store that as if the prefix currently is going to be the whole first string, because we just proved that it cannot be longer than this one. And now we will try to compare this string with the all the other remaining strings to see that till what point we are true or we are correct. So first we will compare it with the word flower. So if we see that whether the flow is part of the flower, we only need to compare the first 4 characters. If they are equal to each other, we can simply say that this is still the longest common substring, which is the case in this case because this flow is part of this flower. So far the longest prefix we have found is going to be the first string in itself. Now we will repeat the same process once again. Now we will try to compare flow with float. Now flow is not part of the substring float. So what we can do is we will try to get rid of the last character. Because we are trying to check for the prefix, we are now only going to check for the first three prefix. So now we will compare flow with float. And we can see that this flow is actually a prefix of this float, which means so far the longest prefix that we have been able to find is FLO. Now we also get rid of this one, and now we will move on to the next value. So once again, we are comparing flow with flight. Now currently flow is not a substring of flight, which means we will once again get rid of one character and try to check if FL is the part of the substring. Currently FL is actually part of the substring. So in the answer we found, and since there are no more strings left, we compared every single string and we found out that FL is the common substring amongst all four strings, and that's why we are going to return FL as the answer. Now let's assume that for some reason this last character is something random. Let's say that this last character is ABC. Now once again what we will do is at this step, once again, now with this FL is our prefix that we have been able to find, and we are going to compare this with ABC. Now since we cannot find FL as part of this ABC, so once again we will get rid of L and we will only compare F. F is also not a prefix of this ABC. So in this case, since we cannot find any value inside the prefix, so we will simply return an empty string. So this is the simplest logic to solve this problem. And if we see time and space complexity in this case, the time complexity is actually going to be the sum of all the strings big O of S. Also every single character inside the string would be the total worst case scenario time complexity, which is pretty reasonable because these are very quick operations, and this is still like big O of n time complexity if we consider n to be the total number of characters. And space complexity is actually going to be big O of 1, because apart from using like few variables, we are not using any extra space, so which is wonderful. Now let's see the coding solution for this one. So now first of all we are going to check for the edge case that if the given string is equal to null or strings.length is equal to 0, then we can simply return as an empty string. If that is not the case, we are going to mark the very first element inside the strings array as our by default prefix, and then we will start comparing prefix with all the other remaining strings inside the given array. So we have noticed that in our for loop that we are iterating over the strings array, we are actually starting with I is equal to 1 because I is equal to 0 has already been taken care of. And then after iterating over it, now we are simply going to check for every single string compared to our prefix. So we are only going to check that whether this given prefix is actually an index of the given string. If that is not the case, if that is not equal to 0, which means we will have to subtract one character from our given prefix and once again recheck this possibility. So we will keep on iterating this process. And if at any given moment we identify that the given prefix is empty because continuously we are subtracting one character, if that is the case, we can simply return as the empty string. If that is not the case and we get out of the loop, then we can simply return whatever the value we find inside the prefix variable. So this is it. Now let's try to run the code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs 100% faster than all the other solutions. Also, it is excellent in terms of space complexity as well. And once again, I'm going to be submitting this inside our GitHub repository. So this is the GitHub repository that I'm talking about, where I have solved hundreds of LeetCode problems, and all of these are some of the most popular LeetCode problems that has been asked at bunch of different companies hundreds of times. So if you feel that you are stuck with any of the LeetCode problem, I would highly encourage you to come over here and check for the solution. Also, I have created this document on Google Drive where in this document, first I'm providing all the full courses that I have completed so far, but the most important point for this document is actually this list of all the 130 questions. If you see, these questions are divided based on the topics, the difficulty level, and also how many times they have been asked by separate companies. So this is very important information for any single one of you who is currently just trying to improve on the data structure and algorithm related LeetCode problems, or actually preparing for different interviews, because I know times are tough, companies are laying off people left and right. So it never hurts to be interview ready and always be on your best game. Can see that this has been a very well like problem and also a LeetCode easy problem. Basically, we are simply given an integer n, and for this integer n we need to return a string array called answer, and we are being told to return one index array. These are just all of these things to make it slightly more complicated, but this is a very easy problem. So what we need to do is we need to iterate over until this n values, and for every single value we need to check that if that value is divisible by 3 and 5, we need to return Fizz Buzz. If it is only divisible by 3, we need to return Fizz, and if it is only divisible by 5, we need to return Buzz. And if none of these cases apply, then we need to return the value as it is, but instead of integer we need to return the value as string inside the string array. So let's try to understand this with a couple of examples. Let's say that if we are given number input n is equal to 5, in this case we will need to iterate over values from 1, 2, 3, 4 and 5, and for each one of them we will have to create a string array. So let's assume that this is our array. Now this value number 1 is not divisible by 3 or 5. So in this case we are going to return 1 as the string value as it is. Same way 2 is also not divisible, so we are simply going to return 2 as it is. Now at value number 3, if the value is divisible by 3 and not divisible by 5, this is the condition met over here. In this case we can check, we need to return Fizz as the answer. So over here we are going to answer Fizz because this value is only divisible by 3. Same way 4 is not divisible by 3 or 5, so we can just simply return 4 as it is. And for the value number 5, since it is only divisible by value number 5, we need to return Buzz as the answer. And this is what we need to return. All we need to do is we simply need to create a for loop for the given n value, and then we need to iterate over every single value, and we need to create the conditions in such a manner that if the value is divisible by 3 and 5, in this case we need to add Fizz Buzz for the new list we have created. If that is not the case, once again we can have an else if condition, and again if the value is divisible by 3, then in this case we need to add Fizz. If it is else if it is divisible by 5, then we need to return or add the word Buzz into our array list. And if none of the case is there, then whatever the value of I is, we need to add that value of I into our array list or array, and that's it. So this is the whole solution. If we see the time and space complexity, time complexity is simply going to be big O of n, where n is the number of inputs that we are given, and space complexity is, you can debate this with your interviewer because we are being asked to return a new list. If we consider that an extra space, then it would be big O of n. But if that is not the case, then in order to run this code, we don't need any extra space. So we can just complete this whole solution in big O of one time. So for the problem, first of all, we are initializing a new array list called result, where we are going to store all the values. Then as mentioned, we are iterating over every single value inside the given input, and the starting value is 1 because we are being told that this is a one index array, just a small tweak. Then we are having bunch of our conditions, and first condition is if the number is divisible by 3 and 5, we need to add word Fizz Buzz. If that is not the case, and else if it is only divisible by 3, then we add word Fizz. If it is only divisible by 5, we add word Buzz. If none of the case is there, then we simply add the value as it is, but we add the string value of I, and then in the end we simply return the result. So let's try to run this code. And as expected, our code runs successfully. Let's submit this code. And our code runs pretty fast compared to all of the other solutions, and also pretty efficient in terms of space complexity. But I don't even think that this matters that much. This is a really easy problem. Now, as promised, let me show you some of the important resources that you can use in order to prepare better for your upcoming technical interviews. I have actually created some resources. I have also stored all the code that I'm doing in a GitHub repository, and also some of the important YouTube channels that you should always check out if you want to gain much more insight into how IT technology works, what are the new things happening in the IT industry, and any of the thing that you want to learn. So without any delay, let's get started. So the number one thing I want to show you is this document that I have created, where I have posted some of the full courses that I have created on various topics like data structure and algorithms. Funny thing is I have actually solved the entire blind 75 and I have already put it in a single video. So I have mentioned that over here, and also some of the other important items that you should learn if you want to prepare better for your technical interviews. Next, we have this list of 125 or I think 130 questions. Amongst these questions, I have sorted these questions based on the difficulty plus based on the topic. For most of the videos, most of the problems I have created video solutions. So if you are not able to find it, you can go to the video solution. Also, these questions are actually LeetCode links for any particular question. And the important part is that I have actually divided it by the number of times it has been asked by different companies. Now I know that not everyone wants to get a job at FAANG company or some other company, but needless to say, if you are preparing for a tech interview, this would be very much helpful because it would give you an idea that how popular that particular question is, at what frequency it has been asked. And if you are directly preparing for those specific companies, say for example, if we see this problem race car, so this problem has been asked by 92 times at Google, which means if you are preparing for Google, you should understand that these are the type of questions that you are going to encounter. So it can be really helpful with your prep journey that you are doing. So this is the list of all the questions. Next, I have also portrayed down the experience of all the technical interviews or all the major interviews I have had in my career. And I have also provided that which are the interviews I got selected, which are the ones I got rejected. And actually I got rejected at hundreds of companies, but I haven't put all of them. I just put like some of the popular ones where I had some good experience. And then we have this GitHub repository. So if we go to this GitHub repo, it contains a lot of important information about all the problems that I have solved so far on the LeetCode. So many times I can understand that on the LeetCode, if you need the information, you might need to have like a paid version, and readily the items may not be available. So for most of the popular questions, you can actually go here and you should be able to find appropriate solution for that. So this would be really helpful to a lot of people. Now, the important resource that I was talking about, if you are preparing for your tech career or your interviews or your journey, I would really encourage you to go and check out this channel, freecodecamp.org. Now, for sure, they don't need any introduction from my side. Like, as you can see that they have like millions of subscribers and also thousands of videos on their channel. But good thing about this is that all the videos are actually full-fledged courses. So if you are interested to learn any new technology, they probably have a course for that. Funny thing is, I actually created and uploaded a couple of courses on this channel as well. So first one is Master Behavioral Interviews, and second one is, I think it should be popping up soon. And yeah, second one is Master Technical Interviews. I am also in preparation to create more courses for this channel because I personally feel that this is much more advantageous and it reaches to a lot of broader people. And this is like few of the resources, and let me know in the comments if you want to see more resources related to different type of stuff, like maybe technical system design concepts and system design interviews. So I can also share that in the upcoming videos as well. Hello friends, we are not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do longest repeating character replacement lead code problem that contains very important properties related to string based problems. If we see the companies where I want to get a job and that have already asked this question, there are companies like Google, Amazon, Uber, Adobe, Facebook, Apple, Bloomberg, and Microsoft. So some of the top tier IT companies. So that's why I am paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem, and basically we are given a string s and we are given an integer k. Now we are told that inside this given string s, we can replace any character with any other character in the English language, and we can repeat this operation k times. Now, after repeating this operation, what is the main purpose of this question is that we need to return the length of the longest substring that contains the same letter by doing this replace activity, and we need to return that length. Okay, so now we will try to understand this problem with this example. So suppose we are given our s is equal to a, b, a, b. and we are told that k is equal to 2, which means we can replace any two character with whatever two characters we want. So in this case we have two options. Either we replace these two b's with value number a, then we will get a string that looks like a, or we can replace these two a's with the letter b, and then we will get a string. Our concern is we don't care what is the value of the string. Our aim is to find the longest substring that contains all the repeated character, and we need to find the length of it. In both the cases, the length of these two is actually 4, and this would be the answer we need to return. So this is what the problem is asking us to do. Let's take one more example to make our understanding more clear. So suppose our given s is equal to hp. If this is the case, and our given k is equal to 2 again in this case. So now if we see the options we have, we can replace like these two p's with the value h. So that will give us a string like h. And so if we see the longest substring that contains the same letter, the length in this case becomes 5. Second option we have is that we choose any two h value, suppose these two, and we replace it with value number p. If we do that, we will get a substring that looks like this. So in this case, if we see that what is the longest length of the subsequence that contains the same letter, it's actually 4. So this is 4 and this is 5, and we need to return the longest. So that's why this is the most optimal way to approach this problem in this case, where we are going to replace these two p values with the letter h, and we don't do this p operation. So there are few ways to solve this problem, and there is also a brute force way to solve this problem. So first I'll show you the brute force way, and then we will see that what would be the optimized approach. First of all, we identify that what is the thing that we want to find. We want to find a substring, and then we want to replace the characters, and then we want to find a substring that contains the longest length with the same characters, right? So first approach we can take in the brute force is that we take every single substring that is possible. So even if we just see that substrings that starts at a, we will get substrings like a, b, and a, something like this. Again, if we see substring that starts with b, we will get b, and so on and so forth. So we would end up with bunch of different substrings. Then we will start this replace operation on all the substrings, and eventually we would find some substring that will look like this a, or this b. And in any case, we would be able to return the length as 4. Like, okay, this solution would work and we will get the desired result, but there are a lot of issues with that. Even if we just see that for a single character, we end up with like so many substrings, and we still have more substrings to go to. So this is a very inefficient approach, and we should avoid doing it at all costs. Okay. Before we come up with the optimal solution, first of all, we will have to identify that what is our need. Our need in this case is that we are given this string, and we are told that we can replace any two characters inside this given string with any other characters because k is equal to 2. Now we need to find a substring where all the characters contains the same value, and because they contains the same value, we need to return the length of it. So first of all, we will have to identify that what is the substring where we can actually create all the characters of the same length. So first of all, let's see that can we apply this thing on this whole substring for this entire string of all the 5 characters, and this given k is equal to 2. So first of all, we will try to identify that what is the number of occurrences of every single character. So a occurs 2 times, b occurs once, c occurs once, and d also occurs once. So which means that because a occurs most of the time, our logical or rational conclusion is to create a substring where all the characters are a, because in that case we will actually have one additional character. If we try to create all the characters with value b, c, or d, obviously we are always going to fall short by one character, because the value of a actually appears twice, which means these 3 things, they have less significance compared to this a, because a is the most repeating character. And why I'm putting so much emphasis on most repeating character, because this along with this k and the length of the string or substring defines that whether any substring we can convert it to all the repeating characters or not. Let me show you how. Suppose in this case we consider all these 5 characters. Even if we replace any 2 characters, in this case we have 3 characters to replace from. If we replace any 2 characters, no matter what happens, we won't be able to create a substring where all the 5 values are actually a. Why? Because we only have the option to replace two elements, and there are three different elements that contains different values. So how we come up with this value that there are three different elements that contains different value than a? Well, what we did was we took the length. So length in this case for this substring is 5. So we took the length of this substring minus we subtracted the most occurred character. So most occurred character in this case is a. So length 5 minus a 2, and this we get 3. So at any case, this value, if that is greater than or equal to this value number k, which means that this particular substring we cannot do anything about it. We cannot convert into a valid or legitimate substring where all the values contains the same character. But if we just shorten our search, if we try to search in these four characters, okay, now what is the breakdown of the number of occurrences of every single character? Well, a still occurs twice, b occurs once, c occurs once, but d is not appearing, so we ignore this one. Now in this case, the length of this is equal actually 4, which means that if we apply the same formula, that length minus whatever the maximum occurred value, so maximum occurred value is still a, which means that we do 4 minus 2. So 4 minus 2 is 2, and this 2 is actually equal to whatever the value of k is. Because this is equal to k, and in this case we can define that for this particular substring we can actually convert it to all the characters being same by using this replace function. And if we just replace this value b and c, we will get actually a substring that is all the a's, and this is the answer. So basically this is the critical part. Now remember that in order to generate this, what are the things we needed? We actually needed that what is the current length of the subsequence that we are following, or what is the length of the substring that we are doing. We actually need to know that what is the maximum occurrence of any particular character in any given subsequence. And we also needed that what is the value of k. Based on it, we were able to identify that whether any subsequence can it be converted to having all the characters to have the same value or not. And based on this concept, so formula we can create is that a valid subsequence is a subsequence where the length of the subsequence minus the most occurred character. If this one is actually less than or equal to whatever the value of k is, if this is true, then we can say that this is a valid substring, and the length, whatever the length of this particular substring is, that is also the length of the substring which contains the most repeated characters. Let's see it with an example. Okay, suppose this is the example that we are given and we want to solve this one. First of all, we are going to see that what is the formula that we have to use. Well, the formula we have to use is that for any subsequent to be valid, what we are going to do is we are going to do length minus whatever the max occurrence in that particular subsequence, and we will see that if that value, if that is less than or equal to k, if that is less than or equal to k, whatever the length is, we can treat it as our answer, and whatever the maximum answer we find so far, we will conclude it as our solution. We already know this formula. Now we need to see that how can we implement that. Basically, we are going to use a sliding window plus 2-pointer solution. And inside this solution, what we are going to do is we are going to have two variables called left and right to be initialized at the first position. We are going to update the right value to the next element. Then we will check that whether the substring is valid or not. If the substring is valid, we will calculate that what is the answer. We will update the answer. Again, we will move the right value, and again we will move the right value. Again, we will move the right value until the point when the substring is not valid. The moment the substring is not valid, we can conclude that now we need to shrink our substring. So basically, suppose the r is now at this position, we will have to update the value of left. So we will ignore this element and we will move our left value over here, and then subsequently we will keep moving on, and every single time we will keep track that what is the maximum answer we have found so far, which is the longest repeated character substring, the length of it. And whenever the r reaches at the end of the list or at the end of this string, we can conclude that whatever the value we have stored in the answer, we can return it as the answer. So now because we are using this two pointer approach, we know that at any given moment what are the things we need. Well, we need couple of things. First thing we need is we need this length. So length we can identify based on the difference between this left pointer and right pointer. That gives us the length of the current substring. Now we need to know that what is the maximum occurrence at any given moment of any particular element. So we don't know that, right? So what we can do is we can actually create an array of size 26. So one for every single character in the English language, because we know that there are only 26 characters. And whenever we find any value on the right side, we will add that value to our array. Or if we move any character on the left side, we will reduce that value from our array. So at any given moment, we would always know that what is the maximum value we have at any given position. And let's see by an example that how we will complete this operation. So let me quickly show you an example that how we will iterate over for this given example. Let me clean this up a bit. Okay, so initially our left value and right value are located at these two positions. We are also going to have an array to store the maximum occurrence of any single element. So currently I'm just showing you the elements that are coming in, but that is the idea that we will keep in mind. So first of all, currently the value is p. So we will add p over here, and we will notice that okay, the occurrence of p is one time. Just this is for understanding purposes. When we do the code, it would be slightly different, and I will explain it to you when we would be coding. Now so far this list has to be valid because there is only one character, right? Now we will update the value for r. So this is x, and x is also present one times. Now we will see, so current length of this string. So now r is located over here. Okay, so current length is actually 2. And what is the k value? K value is also 2 because that is constant, so that won't change. And what is the maximum occurrence of any character so far? So maximum occurrence is still 1, as we can see over here. So maximum occurrence is 1. So if we apply this formula, 2 minus 1, so 2 minus 1 is actually 1, and 1 is less than or equal to value of k, so that is true. So because this is true, we can say that the length of at least 2 characters can be part of the answer. So we will mention that in the answer. Now again we will update the value of r. So now r comes over here. Because r comes over here, we will update the value of q over here, and we know that it occurs one time again. So the length, so the current length is actually 3, and the maximum character is still 1. So we will do 3 minus 1. So 3 minus 1 is again 2. 2 is still less than or equal to value of k. So this is also true. Because this is true, the current length can be part of the answer. So we will update our answer to have the value 3. Now we will again update the value of our r. So now r will go over here, and this is x. So for x value, we already have 1 as its occurrence. Now x has the occurrence 2 times. So we will update the occurrence of maximum number over here called 2 times. The length also increases, so length will become 4. Now again we will try to see that what happens with our equation. So we will do 4 minus 2. So 4 minus 2, this is 2. 2 is still less than or equal to k, which is 2, which means that we can update the answer to the value 4. We will update the answer to be 4. Now again we will update the value of our r. Now r moves one value to the right. Now this is y. Y is occurring 1 times. Now the current length is 5, and the maximum value we have is x, which is 2. So far we are good. Now we will try to do 5 minus 2. So 5 minus 2 is actually 3, which is greater than k, which means that this condition is not satisfied. So because this condition is not satisfied, what we need to do is we need to update the left element. So we will update the left element over here. So now left comes at this place, but because we are updating the left element, we will also have to remove this 1p over here. So we will remove p from here, and now we will update the value. So now length will become 4. Again maximum occurrence is still 2. So 4 minus 2, that is 2. 2 is still less than or equal to k, which is good. So far we are good. Now again we will update the value of our r. So now r comes at this place. Because r comes at this place, the occurrence of x comes to 3. Now because this comes to 3, we will update the value of maximum occurrence to be 3, and we will update the length to be 5. Now we'll do 5 minus 3. 5 minus 3 is 2. 2 is still less than or equal to k. So because 2 is still less than or equal to k, we can update our answer as well to the whatever length we have found, which is 5. So we will update our answer to be 5. Now again we will update the value of our r. R comes over here. Now this is a. We don't have any entry, so we will add an entry for a, and we will call it as 1. Now in this case the length is 6. length is 6, but maximum number of occurrence of x is still 3, which means that now we can do is 6 minus 3. So if we do 6 minus 3, 6 minus 3 is equal to 3. 3x is actually greater than k, which means this condition is not satisfied. So now we will have to update the value of our L over here. So now we will get rid of 1x. So because we are getting rid of 1x, the current maximum occurrence we have so far is 2. Okay, now our left is located at this position. Now the length is 5, and the maximum we can make, maximum occurrence is 2. So again 5 minus 2 is still 3, which is greater than k. So again we will have to update the value of our left. So now this time left comes over here, and we will ignore this q, which means the value of q becomes 0. So I'll just remove that entry. Now again this time the length is actually 4, and the maximum occurrence is 2. So 4 minus 2 is still 2, which is actually less than or equal to k. So because this is less than or equal to k, we know that okay, length 4 is can be our answer, but our answer is already 5. So there is no point in updating length to be 4. Okay, next what we are going to do is, now this time we will have to update the value r. So when we update the value r, we actually reach to the end of the string, and because we reach to the end of the string, whatever the value we have stored in the answer, we can return it as our answer. So in this case the answer is going to be 5 from this sequence, and we can mention that after doing 2 word replacement, the maximum substring we can make that contains all the same characters inside this given original string is actually of length 5, and that is the solution. If we see the time and space complexity for this one, the time complexity will actually be big O of n, where n is the number of characters that are present inside given s. Now you will think that okay, in order for us to find the maximum occurrence, actually we will have to iterate over this entire array, and it might take like there are 26 entries, so we might have to do this work 26 times. But the thing is, we are actually going to use a clever trick over here. What we are going to do is, at any moment we update our right pointer, at that moment only we are going to update our maximum occurrence, because remember, our maximum occurrence can only increase when we update the value of our right. Whenever we update the value of our left, we essentially decrease the whatever the maximum count we have, which means that our maximum count is never gonna go high. So that's why by using this clever trick, we can actually reduce the time complexity to big O of 26 times n to only big O of n, and you will see it in the coding. Also in terms of space complexity, we can conclude this actually 2 times. We can either conclude this to be big O of 26 because we are storing an array of 26 characters, or we can consider this as big O of 1 or constant space, because this 26 is a finite number. This is not an infinite number. So that is why depends on your interviewer how he wants to treat it, and that way you can take it forward. Now let's move on towards coding now. First of all, we are going to create an integer array to store the occurrences, and we are going to name it as occurrence. Now we will create few variables. So first of all, we will create variable left and right, and we will initialize it to value number 0. Now we will create a variable called answer, and we will initialize it to 0 as well. Also we will initialize a variable called maximum occurrence. Now we will run a for loop on all the characters of given string. So first of all, we will calculate that whether we need to update the maximum occurrence or not. So now we will check that whether the current substring, if that is valid substring or not. So we are going to use an if condition. First of all, we are going to check that whether the length, so in this case length is going to be right minus left plus 1. So if the length minus whatever the maximum occurrence is, if that is greater than k, which means that which means that the current substring is not valid. If that is not valid, we will have to update the value of left variable, and we will also have to decrement the value that is located at current left counter on the given string. Once that is done, for every single update, we will have to check that whether our answer is the longest string or not. So we will check that what is the value of our answer. That should be it. So after this loop ends, basically we should have our answer stored in the answer variable, so we can simply return that. Let's try to run this code. This should have an occurrence. Okay, seems like our solution is working as expected. Let's submit this code. Oh, our solution is not working. Oh, we need to decrement the value first before we update this left pointer. So let's try to run the code again. Okay, let's submit it again. Seems like our solution is working as expected. Hello friends, we are still not employed by FAANG companies, so stop lead coding till we get there. Today we are going to do longest substring without a repeating character lead code problem, and this is actually number 3 problem in the lead code and also very popular problem. As you can see the number of companies that have already asked this problem. So if I just check the companies where I want to get a job and I have already asked this question, there are companies like Amazon, Microsoft, Facebook, Bloomberg, Apple, Google, Spotify, Uber, Goldman Sachs, Yahoo, Walmart, eBay, Lyft, ByteDance, Morgan Stanley, and Paytm. So that's why I am paying my utmost attention to solve this problem. I hope you also enjoy the video. So this is a LeetCode medium problem and also one of the most liked problems on LeetCode. Basically, we are given a string S and we need to find the length of the longest substring without a repeating character inside this given string. So suppose in this example, we are given a string like this. And in this case, if we check that what is the longest substring without a repeating character, that is this one ABC, and the length of this is 3. We can also conclude this one as well. This has also length of 3, and we can return either of them, but the answer in this case we are going to return is actually 3. Let's see that what would be the different approaches to solve this problem. So suppose this is the input that we are given, and let's see that how can we solve this in a brute force manner. Well, the most basic idea is that we can take this input and take every single substring that is possible and then check on all of those substrings that whether there are any repeating characters or not, and whichever the substring with the longest length we found without any repeating characters, we will just present it as an answer. So if I just show you by an example, in this case the number of substrings we can make is, okay, let's start from this A. So from this A we can make a substring of A, we can make a substring AB, we can make a substring ABA, we can make a substring ABAT dot dot dot, and so on and so forth. We can make all of these substring. Next substring we will make starting from this value number B. So from B we can make B, BA, BAT, BATM, and so on and so forth. So in this case, the longest substring we would be able to make is actually this one BATM, that is of length 4, and this is the answer in our case. So even if we use the brute force approach, eventually we would have found this substring by comparing all of the bunch of different substrings that we would have created, and then we would have written 4 in this case. But what is the issue with this approach? Well, the issue is actually quite trivial, that we are actually doing a lot of unnecessary work and we are trying to find a lot of different substrings. Even if we just see the time and space complexity in this case, the time complexity is actually going to be big of n cube. Why n cube? Because we are going to do n square work to find all the substrings, and then we will have to do n work for every single one of them to find that whether there exists any repeating character or not. So this is a really bad approach. Let's see that what is the improvement we can make. To optimally solve this problem, we are going to use very important concept called sliding window, and in addition with 2 pointer. What we are going to do is we are going to have 2 pointers called left and right, and these left and right pointers, we are going to have them to follow a very important property, and that property is that between these values of left and right, all the elements has to be unique. If at any moment we encounter that there is a duplicate entry, which means that we will update the value of L to the point where the duplicate entry is mitigated or it's eliminated, and then we will again keep on progressing with this right pointer. Let me quickly show you how we are going to do that. So first of all, left and right both are going to start at the same position. Now we are going to make our right pointer move to the next element until the point where we find a place that is actually repeating. So we are now, our right pointer is at this position, our left pointer is at this position. So far we have 2 elements in our substring and both are unique. So because both are unique, we are good up until to this point. Also at the same time, we are going to have an answer variable where we are going to store the length of the maximum substring we were able to find with all the unique characters. So far initially this value was 1, but now we have found that there are actually 2 elements for this substring that has all the unique elements so far. Now we are going to update the value of our right pointer again. So right pointer will come over here. Now again right pointer is here, but at this point, okay, we need to check that, okay, amongst this A and B, does A exist somewhere? And we know that A exists over here. Now you will quickly ask me that, okay, in this case, since we only had two elements and we were comparing this A, it was really easy for us to identify. What if we had like 10 elements like this, and then we are comparing this A, and we need to check that whether at all these 10 positions does this A exist or not? And that would make things really inefficient, and that would be big of n square time complexity. So what we are going to do is we are going to have a visited hash set, and inside this visited hash set we are going to store all the characters we have found so far between L and R, and we are going to keep on adding until the point we find a repeating character. So initially this only had the value A when we are at this point, then we added a B. So far inside our hash set we actually have A and B, and now when this R pointer comes at this position A, first of all we'll check that whether A exists or not, and we realize that, okay, A exists inside this hash set, which means that amongst this substring we cannot add this value A because A exists over here. So now what we are going to do is we are going to remove A from this our set, and we are also going to update our left pointer to remove this value A. So okay, we ignore this A, and now our left pointer is at this position, our right pointer is at this position. So far the values are B and A, and now we are again going to add this value number A over here because this right pointer is here. Okay, what is the length so far? So the length is still 2. So because length is 2, we are not going to update in our answer, because in our answer the length is also 2. Now we are going to update our right pointer to come to the next element, and when we update the right pointer, it comes over here. So this t does not exist inside our hash set, so we will add entry t over here, and our we will update our answer as well. So now our answer becomes 3. Now again we will update our right pointer to come over here. So when the right pointer comes over here, we will have an entry M. So again we will add the value M over here inside our hash set because it does not exist before, and we will also update our answer to be of length 4 so far. Now again we will add our right value over here. So when we add the right pointer over here, and at this moment this is A, so we try to check that whether A exists in our hash set or not, and we can realize that, okay, A exists already. So immediately, because A exists, now we will have to move this left pointer up until the point where we encounter this A. So okay, this B, we can ignore this, and we'll jump our left pointer. Okay, left pointer comes over here, and again this is A. So again we will ignore this, and then we will come for the left pointer to be over here, which means that left pointer is going to be here and right pointer is going to be here. And also at the same time we will have to remove this B and A from our hash set that we were currently visiting. So currently the entries we have is T and M only, and then because this right is at this position number A, so we are going to add an entry for A. Now we are going to update and so far the length of this one is actually 3, so we don't need to update in our answer. And then again we are going to update the right pointer. So right pointer comes over here, this is N does not exist inside the hash set, so we will add an entry called N over here, and then this length is actually 4, so answer is 4, so we don't need to update so far. And then if we try to do next to this right pointer, we come to the end of the list, and the string is empty now. So because we are done iterating over the entire string, now all we need to do is return whatever the answer we found in this case, and the answer we found in this case is 4, and that would be our final solution. So if we see the time and space complexity in this one, it's actually really efficient. So in terms of time complexity, we are actually completing all of these things in a single iteration, so it's actually big O of n. And in terms of space complexity, we are using this additional hash set to store the value, and the space complexity at any given moment is actually going to be big O of whatever the answer we have, or whatever the longest increasing subsequence we have. Because remember, at any moment we are only having that whatever the maximum number of unique characters in the substring we have. The moment we increase the moment we encounter a repeating character, we are actually getting rid of all of them. So that's why the space complexity is going to be big O of whatever the longest repeating character we have found so far. So first of all, we are going to check couple of edge cases, that if the given string is empty or if it only has one character, then we will return So now we are going to initialize couple of variables called left and right, and we are going to initialize its value to 0. We're also going to initialize a variable called answer, and by default we are going to have the value as 0, and we are going to initialize a hash set of characters. So first of all, we are going to run a while loop till the point where right reaches to the end of the string. First of all, we are going to initialize a character variable and to find the value of that particular index. And then we will check that whether this value exists inside our hash set or not. So if the value exists inside our hash set, we are going to remove it from our hash set, and we are also going to update the value of our left pointer. And if the value does not exist, we are going to add it to our hash set, and then we are going to calculate that whether the current answer we have is actually greater than whatever the answer we had before. And we are going to do right minus left plus 1. And at the end we are going to update the right pointer as well, and that should be it. So when both of these loop runs and after it ends, we should have our answer inside the answer variable, so we can simply return that. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's try to submit it. And our code runs as expected. I will be posting this solution inside the comments. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do minimum window substring problem, and if we see some of the companies where I want to get a job, there are companies like Facebook, Amazon, LinkedIn, Microsoft, Lyft, Airbnb, Apple, Adobe, Google, Snapchat, Flipkart, ByteDance, Spotify, TikTok, Bloomberg, Uber, Pinterest, and Goldman Sachs, who have already asked this question. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode hard problem, but it is also a very well liked hard problem. Basically, we are given two strings called S and T, and we are given the lengths M and N respectively for each S and T strings. Now we need to return the minimum window substring of given string S such that every character in T, including all the duplicates, that is the key part, is included in the window that we have created from this S. And if there is no such window, then we need to return the empty string. So if we try to understand this with an example, if we take this example, for instance, we are given a string S that looks like this, and we are given a T that looks like this. Now we need to return a substring in this given S such that this A, B, C is present. Now we don't care about the order of this A, B, C. They can be in any order in the new substring that we are trying to create, but we need to return the smallest substring. So if we see one of the substrings that where this A, B, C is present, we can find a substring that looks like this. If we see this particular substring, for an instance, we can see character A, B, and C is being presented. But the thing is, the question is this the minimum window substring? No, this is not the minimum window substring. Why? Because there exists actually a smaller substring where A, B, C is also present, and we can take one more substring that looks like this. So this substring is smaller than this first one, where also A, B, and C is also present, though they are in different order. But this is again not the minimum substring. There is actually a substring which is B, A, and C, where all the values of A, B, C is present. That is continuous substring of this S, and this is the minimum substring where we can find all the characters that are present in T, and we need to return this as an answer. If we see couple of more examples over here, suppose we are given S is equal to A and T also equal to A, we can simply return A as the substring because that is the only substring we can create. Now if we are given S is equal to A and T is equal to double A, which means that there is no way possible for us to create double A from this single A. So in this case we need to return an empty string. So now since we have understood the problem, let's see that what would be the different approaches to solve this problem. So first of all, I'll show you the brute force approach, and if you directly want to check that what is the optimal solution, I have already provided the timestamp, so you can directly jump onto the optimal solution as well. Okay, Suppose this is the S and this is the T we are given. We are looking for a substring inside this given S, which contains all the letters of this T, and we need to find the minimum length substring for that. Now we can clearly see that there is one substring HBPO which contains all of the elements that are present in T, but the smallest substring we need is actually OBH, which contains all the elements of this T, and that contains the smallest length. The brute force way to solve this problem is that we actually start creating every single possible substring out of this given string S. So we can create substrings like, we will check that okay, this can be a potential answer, we will put it as a potential answer, and we will mark its length. Now eventually we would find a substring that looks like this OBH, that is the correct answer, and then we would return this answer as our solution. So this solution will also guarantee to provide us the right answer, but this right answer is actually very costly. Why very costly? Because we know that it takes big O of n square to actually create all the substrings, and for every single substring we will have to check that whether it contains all the elements of T or not, which means we will have to multiply this by the whatever the length of T is, which is let's say m in this case, which means that we are actually essentially doing big O of n cube work to solve this problem, which is very expensive. Okay, suppose this is the example that we are given, and we are trying to find that what is the minimum substring inside this given S where all the characters of this T is present. So to optimally solve this problem, we are actually going to use sliding window technique with 2 pointers. So now I have presented the input in a slightly different format, and I have also created that what is the answer we are going to store, because remember in the answer we need to return that what is the minimum substring, and for any minimum substring we need the left pointer and right pointer value, and we also need the length, and we will only choose the minimum length. Now initially we are going to have our left and right both pointers starting at the first position, and now what we will have to check is that we are going to have our right pointer go on the right side until the point where we create a substring where all of these A, B and C are present. The moment we do that, we will note down that what is the answer we have found so far, what is the minimum length, what is the left pointer, what is the right pointer. Once we do that, we will start updating the value of the left pointer to go on the right side until the point when this condition is no longer true and we are not able to make ABC in the given left and right string. And again we will update the process on our right portion, and then again we will try to see that whether we can find a better substring or not. So let's see this approach in action. So now to achieve this approach, what we are going to need is that we already have our 2 pointers left and right over here. Now we need to check that at any given substring whether this T is present or not. So if we for every single substring try to check that whether all of the characters of T is present or not, it takes a lot of time. One quick way to do it is that we actually create a hash map for all the characters that are present inside this value number T, and inside the hash map we note that what is the elements and what are the number of occurrences they have. So in this case, for this T hash map, we actually have 3 characters only, and we have 1 occurrence of each of them. So we are going to note it somewhere so it becomes easier for us to record. Now at the same time, for any substring that we create, we will also have to check that whether we have all the satisfied words inside our substring or not. So again we are going to create a hash map for our substring that we are creating as well, and inside the substring hash map we are going to keep on adding the values as we move forward. Now to check hash map every single time is not a very good approach. A better approach in this case could be that we already know that what are the number of unique characters we need inside this hash map. So why don't we just create 2 variables called the number of unique characters. So we just name it as unique that are present inside this T hash map from this given original input, and whatever the substring inside the substring, whatever the unique characters that we have already been able to create. So let's just say that this name is create, and we will keep track of it, right? I'll just show you that how we are doing everything when we keep moving forward on the with our example. So initially left and R both are at this position, and currently we will note that okay, A is not present inside our given substring, so we will add an entry for A, and so far we have received 1 occurrence so far, right? Now originally this T hash map had 3 unique characters, so we are going to note that there are 3 unique characters that we have to find in any given substring. And so far, because this current right position is at A, we have already found one of the characters of the required occurrence, right? So we will note down that okay, we have already received one of the characters. Now our right pointer is going to the next element because we haven't satisfied our full condition. So now we identify that okay, this value is actually b. So we are going to add an entry over here inside our substring hash map, and we are going to say that we have found one occurrence of b, and this one occurrence of b is already also required inside this given hash map as well. So we can note down that okay, out of this 3 required, we have actually found 2 unique characters that are needed, right? We are good so far. Now next thing we are going to do is that again over here we are going to update the value for right pointer. We encounter that this value is actually a, so we are going to add one more entry to our required pointer. So over here we have found 2 occurrences of a, but that does not solve our problem because our unique and create are still not same. So now we are going to update the value for r again. So now again r is at this position x is not present over here, so we will add an entry for x is equal to 1, but this x is actually not present in this t hash map, so we can't do anything about it. Now again we will going to update our value of r. So r is at this position. Now because r is at this position, remember that this is the value of c is actually 1, c was the remaining value inside this t hash map. Now we have 3 unique characters that were needed, and we have already created 3 unique characters inside this given hash map. So now we are going to treat this substring as our answer, because remember we needed to have the values a, b, c, and a, b, c are actually present over here. This is a, this is b, and this is c inside this given left to right substring. So we have found one potential answer. So first of all we are going to check that okay, what is the length of this one. So length in this case is 0, 1, 2, 3, 4. So length is actually 5, and the left pointer is at 0 position and right pointer is at 4 position, and we are able to add this entry to our answer because we don't have anything before. So that's why we were able to add an entry to our answer. Now we are going to update our left pointer until to the point when this condition is no longer true. So now because previous value of left pointer was over here, and now we jump to this place. So now left pointer is at here, but the moment we updated the left pointer, we will also have to remove the value of our reduce the value inside our substring hash map. So now a there is only one occurrence of a. So far this condition is already true because both this 3 and 3 is matching, right? Now again we are going to update the value of our left pointer to one more character. So now left pointer is over here. Now this b is actually 0, so we are going to remove the entry for b. Now because we remove the entry for b, we have only created 2 elements that are needed inside this substring from this position 2 to position 4, which is a and c. We don't have b entry, which means now we will have to update the value for right pointer until we find the b. Now lucky for us, b is actually very next to this right pointer. So now right pointer is over here and b is actually over here. So b is 1, we will add an entry over here, and now we have already created all of 3 elements needed rather than 2, and we are done with this case, right? So which means we can say that this new substring is also a potential answer. And let's see that whether this substring is actually better than our previous answer or no. How can we determine that? Remember, the aim of this question is to find the minimum length of the substring. So we are going to compare the length of this one. So length of this one is actually 4, and the current answer we had was actually of length 5, which means it is in our interest to update the length over here. And the moment we update the length, we will also have to update the left and right pointer over here. So left pointer currently is at 2 position and right pointer is at currently at 5 position. Now we have found a potentially better answer. Now again we are going to update our left value because we have already found the answer. So now left comes over here, which means we will have to reduce this value of a. So again we are going to reduce the value of a. So a is now 0, so there are no occurrences of a. Because there are no occurrences of a in this new substring, we have only created 2 elements out of this 3 unique characters that we are needed, and which we can see in this particular substring from this position number 3 to position number 5, that we only have c and b, we don't have a. Now we are going to update the value for right pointer. Now again when we update the value for right pointer, lucky for us, we are actually able to find one a. So we will add an entry inside our substring hash set that okay, now we have found one character. Now we can say that we have created all 3 characters that were needed. Now this is also potentially a new substring, and can this be a better answer? So we'll check. Okay, in our length we already have an answer of 4 inside our answer array that we have stored, and this is also an size of 4. So which means that there is no point in updating our answer. We already have the same answer with the same length, so we are going to go to the next case. So now again we increase our value of left, so now left is again at this position, so we will have to ignore this x because we already got rid of it, which means that we have already traveled all the values so far, and now we are at CBA. Now CBA, again this is all of these three elements that were needed, and we already have that, which means that this is also potentially a better substring that we have found, and the length of this is actually 3. So because the length of this is 3, this can be a better answer, so we will note it down. So this is 3. Now left pointer value is 4 and right pointer value is 6, so we have found a potentially better answer. Since we have already found an answer and we know that this is a valid substring, now we'll have to update the value for left pointer. So once we update the value for left pointer, we are actually going to ignore the C. So now we get rid of the C inside our hash set. Now we also get rid of this L, and now we have taken care of all of these elements so far. Now we only have BA, which means we only have 2 elements out of 3 that we needed. Now again we will have to update the value for right pointer. So again we update the value of our right pointer over here. We find that okay, this value is actually C occurrence is 1, which means we have created this element actually 3. All of this is successful. Now we check that okay, length of this is actually 3. We already have an answer of length 3, which means there is no point in updating that. Now we will update the value for left pointer. We will ignore this B. So if we ignore this B, now we only have 2 elements out of 3 needed. So because we have 2 needed, we will have to update the right pointer. So now when we update the right pointer, we are actually going to be at the end of our string, and because we are at the end of our string, we can actually break out of the loop. And the moment we break out of the loop, which means that whatever the value we have stored inside the answer, we have the left pointer, we have the right pointer. So all we need to do is we need to return the substring. So if we return the substring in this case, we will have to return the substring that looks like this. So the answer in this case is actually going to be CBA, which is the minimum substring that we can achieve that contains all the elements of the T that are present over here. And remember, over here we are using hash map and substring hash map to find the answer. In order to make our lives easier, we have created 2 elements to know that what are the unique characters that we need to compare. In case, because this was a string and we know that there can be only a finite number of unique characters, which is 26, we were able to use this technique. But your interviewer is for sure going to ask you that rather than having a string and having finite number of unique characters, you are actually going to have millions of hash code characters or something like that. In that case, you will not use this technique, and you will actually just simply have to check over the hash map for every single substring that you are going to make. So this is one of the approach where we can find the optimal solution, and it works as expected. If we see the time complexity is actually going to be O of whatever the length of string is plus whatever the length of T is. And why we are able to achieve this time and space complexity? Because we are using this technique, so that makes our lives a little bit easier. If we see the space complexity is also going to be actually big O of the whatever the size of S is plus whatever the size of T is, and this also works because we are creating 2 additional hash maps and we need to take care of that space into account. But overall, this is still much bigger improvement in compared to our brute force approach. Now there is one more approach to solve this problem. That whatever the input that is already given, first of all, whatever we create the same hash map we create for this element number T, which means that we actually use the same hash map that I have drawn over here to compare all the values of T. But for this value number S, actually remember that we only need to find the substring of characters that are present in T. But so if that is the requirement, why do we even bother checking this element X or any other element that is not one of these values? So a better way to solve this problem is to create another hash map where we ignore this X and we only keep character inside this given string that are also present in the inside this given T. And in this particular hash map, we also identify that what is the index value for every single element. So in this case, we will determine that okay, this A is actually present at 0th position. Then again we have a B that is present at 1st position. Again we will mention that there is an A that is present at 2nd position, and so on and so forth, and then it will make our lives a little bit easier and we can solve this problem. But I don't think in an interview, even if you show this approach, they are going to completely reject your suggestion. So that is why I am choosing this one. Let me know in the comments if you want me to solve the other approach as well, where we are only going to use the unique characters that are also present inside this given t. So first of all, we are going to check some edge cases if the given string is empty, or if the length of the given t is actually greater than length of s. If that is the case, we can simply return as empty string. Now if that is not the case, we will create a hash map to store the value of this t string inside the hash map for all of its characters. We are going to name it as map t. Now we are going to run a for loop across this given string t, and we are going to add all the entries to our map t. After the loop ends, we are going to create a variable called required that gives us the number of unique characters that are present inside our given map t hash map. Now we are going to initialize bunch of different variables to keep track of different things. So first of all, we are going to initialize variable called left and right to keep track of our 2 pointers. Once that is done, we will create a variable called create that defines that what are the number of variables that we have created so far that are also present inside the given t. And we are going to initialize an integer array to store the value of answer, and we are going to initialize the first value as -1 inside the answer, where we are going to keep track of the length of current substring, and we are going to have 2 more entries to store the value of left and right pointer, and we are going to initialize those values as 0 as well. We will also create a hash map to keep track of all the values that we have found so far inside the current substring. And now we are going to run our while loop across the string s, and we are going to run it until the right pointer reaches to the end of the string. So inside our loop, first of all, we are going to add an entry to our hash map for any particular given substring. After adding a value to our substring, now we will check that whether all the elements we have added in the substring is that element also present inside our map t as well. If that is the case, we can increment the value of number of characters that we have created in our substring that are also required inside our map t as well. So if this condition is true, we will update the value of our create variable. Now after updating that, we will also have to check that whether the current substring, if that is valid or not, and by valid I mean that whether the required and create has the same value. If that is the case, we will have to update the left pointer, and we will have to shrink our size. Also we will have to add entries to our answer array as well. So we are going to run another while loop that while left is less than or equal to right, and the required is and created are same. We are going to check that whether we need to update our answer or not, and we are also going to update the value of the character c variable to help us in doing a lot of other things, and we are going to assign it the value of the current left pointer. Now we check if we need to update the answer. After updating the answer value, we will also have to remove the entry from our substring map because we are updating the left pointer. And after removing the entry, again we will have to check that whether the value of our entry that we just removed, did it caused us to reduce our create variable, which means that have we removed any entry which was also present inside our map t hash map as well, which was required for us. If that is the case, we will have to reduce the value of our create variable, and it could make us break out of this loop as well. In any case, we will have to update the left pointer, so we'll update the value of left pointer. And after that is done, we are done with the inner loop. In the outer loop, we will have to update the value of right pointer, and that's it. So basically after this loop ends, essentially we would have taken care of all the scenarios that are needed for this loop, and now we will work on returning the answer. So for the answer, we will have to check that if the value of answer of 0 is equal to -1, which means that we are not able to find any value that were suitable to create as a valid substring. If that is the case, we will return an empty string. If that is not the case, we will return the value inside our answer array for this left and right pointer value, which means answer of 1 and answer of 2. But we will have to do right plus 1. Why plus 1? Because the indexing works from 0 to r, so that's why we will have to add one more entry to our right. Let me try to run this code. Oh, we made some mistake in generating the answer. Okay, seems like our code is working. Let's try to submit this code. And our code runs as expected, and I would be posting this solution in the comments so you can check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do valid anagrams lead code problem, and if we see some of the companies where I want to work at who has already asked this question, there are companies like Amazon, Facebook, Spotify, Bloomberg, Microsoft, Goldman Sachs, Apple, Affirm, Google, Tesla, Snapchat, Yahoo, and Uber. So that's why I am paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode easy problem and also very well liked problem. Basically we are given two strings s and t and we need to return true if they are anagrams of each other. If they are not anagram, then we need to return false. Now first of all we have to understand that what is an anagram. An anagram is basically a word or phrase that is formed by rearranging the letters and putting them in a different position, and typically we use all the original letters exactly once. So if we try to understand it with an example, suppose we are given a word like bat. So this is the original word. If we just rearrange all of these b, a and t in some other format and keep all of them in the same amount of occurrences they are already present, so we can make some words that looks like tab, bta, atb, tba, and so on and so forth. So these are all words, they are actually anagrams of this original word bat. And how we can identify that? We can identify based on if we see the number of occurrences of all the characters, they are in the same number of occurrences even in the anagram letters as well. So if we try to understand it further, we're using couple of examples. Over here we are given two examples. So this is the example one. We are given two words that are anagram and t is equal to something like this. So if we want to check that whether these two are anagrams of each other or not, what we can simply do is we can start cancelling out or comparing the letters. So a is present, n is present, again a is present, g is also present, r is also present, a is also present, and m is also present, which means all of the letters that are present in s, they are also present in t in the same amount of occurrences, which means we can return true in this case, saying that there exists an anagram and s and t are anagram of each other. Now in this case, s is equal to rat and t is equal to car. If we try to repeat the same example, okay, r is present in both, a is present in both, but this t is not present in this string, and this c is not present in this string, which means these are not anagrams of each other, and we need to return false in this case. So let's see that what would be the different approaches to solve this problem. So the first approach to solve this problem is actually a brute force way, and in the brute force what we are going to do is we take the string s. This string is comprised of three different characters. So what we do is we make all the possible characters that we can make from this given string s. So we can make characters like a c b, b c a, b a c, c a b, so on and so forth. So we would be able to make bunch of different possible words out of this given string s, and then we compare all of them with this given t, and at any point if we encounter that there exists a word over here which is this bca is also present in this all the different pairs we created, if that is the case we will return true in this case. If it is not present, we will return false. So the solution would work perfectly fine, we will get the desired result. But the thing is, our aim is not to get the desired result, our aim is to get a desired result at a convenient cost, so which is not following for this particular scenario. And if we see the time complexity for the brute force approach, it's actually big of n square. Why n square? Because in order for us to create all of these different pairs, it takes us n square time to do it, and that's why we will have to find a better approach. Better way to solve this problem is that we sort the given string s and given string t, and once we do that we will get a sorted string, and then all we have to do is just compare these two sorted strings, because they should, if they are anagrams of each other, they should be exactly same. If they are not anagram of each other, they would not be same. So in this case, if we sort the string s, we will get a result that looks like a b c d, and if we sort the string t, we will also get the result that looks like a b c d. And both the cases, since both the strings are same, we can conclude that this is an anagram of each other, and we can return true in this case. If they are not same for any reason, we will return false. So this solution would work perfectly fine, and we will also get the desired result. If we see the time complexity in this case, the time complexity is actually going to be big O of n log n. Why n log n? Because first of all, we will have to convert this string to sorted string, and sorting takes n log n time. So that is the general time complexity. Now this is still a better approach than our brute force solution, which had the time complexity of big O of n square, and we are actually doing much better, and this is a vast improvement on this. Now we will have to check that is there any way to solve this problem in actually big O of n, and yes, there is a problem. Let me quickly show you how. Okay, so for the optimal approach, we are actually going to use an additional data structure array, and we are going to initialize an array of size 26 for the 26 characters inside the English language, and we are going to initialize all the values to have the value of 0 as the beginning. You will understand that I haven't drawn 0, but you understand that default value is going to be 0. Now the idea is we will start iterating over the string s and this string t. For any single character we identify in this string s, we are actually going to increase that corresponding value inside this given array. So suppose we encounter over here this s, then whatever the initial value of this s is going to be 0, we are going to initialize and increment its value to 1. Again, if we encounter the value I, again we are going to increment the value for this I as well. Now inside this t, we are actually going to do things in the reverse order, and we are going to reduce the value. So the moment we identify any single value, we are actually going to reduce that value from this array. And because we are using the same array, if they are anagrams of each other, remember they have the property that their number of characters and their occurrences should be same. So if they both are same, basically we at the end of our iteration, all the characters inside this given array should have the value 0. If at any point we encounter any value where the value is actually greater than or less than 0, we can determine that these two are not anagrams of each other. So after the explanation, let's try to run it with an example. So first of all, we identify that okay, this character is actually s. So initially the value of this character s is going to be 0, so we are going to mark it as 1. And over here this character is actually l, so the value of this l is going to, we will have to reduce it. So for the character l, we are going to mark its value as -1. So now okay, now next character is I. So again we will increase the value of I to 1, and over here this value is I again. So now we will reduce the value of I as well, so the value of I will remain 0. Now our next character is L. So for L we are going to increase the value. So over here if we increase the value becomes 0. And over here the next character is S. For S we will have to reduce the value. So if we reduce the value becomes 0. Now next character is E, and over here it's T. So for E we will have the value increased to +1. For T we will have value decreased to -1. Again the next character is N and E. So for N we will have the value increased to +1, and for E we will reduce one value, so this value will become 0. Now the last character is T and N. So for the T we will have to increase the value. So original value of T is actually -1, so we will increase it to 0. And this value of N is actually, we will have to decrease it. So the value of N currently is 1, so we will reduce it to 0. Now if we see over here, all the elements where you can see that there are some entries, they are the ones that are the number of characters that are present in this S and T, and all of their value is 0, and by default all the other characters inside this given array was also 0. So it becomes much easier for us to determine that whether they are anagrams or not of each other. In this case we can return true that yeah, they are anagrams of each other. This is the best approach and most optimal way to solve this problem. If we see the time and space complexity, in this case the time complexity is actually going to be big O of n. Why big O of n? Because we will have to iterate over all the characters in S and T one time, and then we will have to iterate over this given array one time to determine if all the entries are 0 or not, and both takes n times. So actually we are doing like 2n work, but we can generalize it to be big O of n. In terms of space complexity, well, this you can argue with your customer, with your interviewer, because we are actually using an array of space 26, so it's like big O of 26, which is a constant value, so you can also consider it to be constant as well. Now whenever you will propose this solution inside the interview, your interviewer is definitely going to ask you that rather than this S and T having only English letters which are 26 by finite number, what if we had a hash code or some other random characters that has millions of value? If that is the case, we will keep track of a hash map, and for hash map every single entry, if we encounter it inside the string S, we will do the increment operation. If we encounter it in string T, we will do the decrement operator, and eventually we would find our answer. So the logic is gonna remain same. This is just the one thing that you will have to understand. Now let's move on to coding. First of all, we are going to check an edge case that if the length of string S and length of string T, if they are not the same, we can return false immediately. If that is not the case, we are going to initialize our array of size 26 and we are going to name it as count. So now we are going to run a for loop across string S and string T, and we are going to increase our counter for any character that is present in string S, and we are going to decrease our counter for any character that is present in string T, and we are going to do both the activities inside the same for loop. For any character that is present inside the string S, we are going to increase its value inside the counter. Character that is present inside the string T, we are going to reduce the value. And after this loop ends, our counter variable should have the correct values. Now we need to iterate over all the elements inside the counter variable, and we need to check that whether is there any value where the counter value of that particular element is not 0. If we encounter any non-zero item, we can return false immediately. And if we break out of this loop, which means we did not find any entries that were non-zero, so we can return true in this case. Let's try to run this code. Okay, seems like our code is working as expected. Let's submit it. And our code is pretty efficient, and I'll be posting this in the comments so you can check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do group anagrams lead code problem, and this problem has been really popular at some of the companies where I want to get a job. There are companies like Amazon, Microsoft, Facebook, Apple, Google, Affirm, Snapchat, Goldman Sachs, Uber, Bloomberg, Netflix, Instacart, ByteDance, and Twitter have already asked this question. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem, and basically we are given an array of different strings and we need to group the anagrams together. Now we can return the answer in any order, so which is good for us. And we are also given the definition that what is an anagram. Anagram is a word or a phrase that is formed by rearranging the letters and then it turns out to be a different word. So if we take an example, suppose we are given a word like bat, then we can say that these all are actually anagrams of this original word bat, because the B, A and T, they are all occurring in all of them in the same number of occurrence that it is present in this bat. So now after understanding that what an anagram is, let's try to see some examples to understand that what this question is asking us to do and what is the expected answer we need to return. If we take this first example, essentially we are given S is equal to array of string that looks like this. Now over here I have clearly marked all the groups that can be potentially done in separate colors, so you can clearly look at them. But the thing is, let's try to understand. So first of all, we are given this word EAT, eat. If we see what are the number of occurrences of characters, there are characters E, A and T occurring 1 times each. Now same thing happens for this word TEAT and for this word ATE8, which means we can conclude that all of these 3 words are actually anagrams of each other, and we can group them together in one single group. So that we are done with all of these 3 elements. Now next item we see there are 2 words tan and net. Again TAN, this all 3 of them are occurring once, these 3 characters for both of these values, so we can also group them together. Now for this BAT bat, we actually don't have any other value that we can consider it as an anagram, so this particular string will be a group of itself, which means in this case we can return an answer that looks like this, and we can return this as an answer. So clearly you would find that this answer, actually the sequencing is done slightly bit different than what is the answer given in this output. And the reason for doing that is that I wanted to show you that we can return answer in any order. So that is the important part over here, that is specified in the question, that we can return the answer in any order. So that's why I ordered them differently, but as long as the groups are correct, we are good to go. One better way to solve this problem is actually by using sorting. And how we are going to use the sorting is that we are actually going to create another array for every single entry that is present inside this original S, and for all the elements that are present over here, we are going to actually sort them in alphabetical order. And then all we have to do is just we will have to iterate over this newly created array once, and we only need to find that what are all the similar pairs or all the similar values, and then we can simply return them as answer, and that makes our life much more easier. Let me quickly show you what I'm suggesting. So based on this array, we will actually create a sorted array, and the sorted array is going to look something like this. So now we have created our sorted array, and which we have derived from this original S. Now all we will have to do is we pick up any word or any string, then we just have to compare with all the other strings and find that which strings contains the same value. Whichever string contains the same value, we will take their values from the original string, because we know that they're index values, and then we can group them together. So the idea is, first of all, we'll take this string AET, then we find that okay, this and this, both of them, so the strings located at position 0, 1 and 3, they are all part of this original string that should be in the single group. So we will group them together. So in the answer we will mention eat, t and 8 as one group. Then again we will repeat the same process. So we find this ant and ant, so again we will group the whatever values located at this string at this index 2 and 4, and we find the values 10 and net, and in the end we will return this bat because it's the single one. So this solution would work fine. We will get our desired answer. If we see the time complexity, in this case the time complexity is actually going to be big O of n log n, just to create this original sorted string, multiply by k, and this k is actually the biggest length of the string that we will have to compare, and this would be the final time complexity. So this is much bigger improvement than our brute force approach, which was giving us the big O of n cube time complexity. Now let's see that can we improve any further in this one as well. Okay, before we come to the optimal solution, we will have to ask a very important question, that how do we determine that any two words are anagram of each other or not? Suppose we are given two words like ABC and CBA. We can clearly see that they are actually anagrams of each other, but how can we explicitly define that they are truly anagrams of each other? Well, we can define that based on the number of character repetition in each one of them, that any character that is present in this ABC, it is also present in the CBA in the exact same number of occurrences that both in both the words. So in other words, A, B and C is present exactly once in this particular word, and it is also exactly once present in this particular word, though the arrangement is different, and that makes them anagram of each other. Now you will ask that why am I dragging so long on this pretty trivial question that we already know the answer to? Well, we are actually going to use it to our advantage, and the good thing for us is that English language only has 26 characters. So because English language has the 26 characters, we are actually going to use it to our advantage. We are actually going to create an array of all the values that are initially located as 0, and that is going to be of size 26. Now any character that we identify in any single string, we are actually going to add it to our array, and we are going to increase the value of that particular character sequence, and then whatever the answer of that array is, we are going to put it in a string, and then we are going to use it as a key for our hashing hash map, and then we are going to do some interesting things. So let me quickly show you that what is the full plan. Suppose over here we are given an array that looks like this, right? Now we have this given word ABC. So what we are going to do is, initially all of these values, they are defined as 0 by default, but now we are given this ABC. So first of all, we take this A, we increase its value to 1. Again we get this B, we increase its value to 1. Again we get this C, we increase its value to 1. Now all the other values, they are 0 so far. So for this particular character, we can actually create a string based on this given array of 26 words. So string would be maximum of size 26, which means it is a defined finite number, which means we can create that. We will get a string that looks like this, 1 1 1, and then remaining 23 zeros. Again we are given this word CBA, right? So again, what we are going to do, first of all, we identify this character C. So we are going to mark its value as initially this was 0. So we are going to mark it to 1. Again, this B, again we will mark it to 1. And again this A, we will mark it to 1. All the other values would be 0. So even for this one, the string that we are going to generate is going to look like this 111 and 000. Now the idea is that we will create a hash map. Now inside this hash map, as a key part, we are actually going to keep track of whatever the string that we are building. So let's just name this as string builder, that we are building a new string. That would be our key. Now in both the cases, notice that for this ABC and for the CBA, this string value is actually going to be the same, that it would be 111 followed by 23 zeros in both the cases, which means that they both have actually same key value, which means that over here, okay, this is 111 23 times. But in both the cases, as the value, we are actually going to keep track of a list, and inside this list we are going to store original words that were presented as an input for this original array string that we built. So over here, first of all, we will have an entry that looks like ABC, and then we will have an entry that looks like CBA. Now we already have both the values that is part of the same group, or they are, and which is an anagram of each other, would be in the list value, which means that makes our life much more easier. That in the end, all we need to do is just we need to return this whatever value we have stored in the list. Let's do this with one of the example that we have been following so far. So I'm not going to show you the whole ordeal with the array because that is too time consuming. I'm just going to show you that what would happen inside the hash map. So this is our hash map. Now as a key, we are going to have some string value. So first of all, we get this value eat. So suppose for this value number eat, we get a string that looks something like this, right? Whatever the value is. Now this same value is going to look for this t and for this 8, which means that these values eat, then t and 8 would be a part of the same value group inside this hash map for the same key. Again, same thing will happen for this tan and net. So even again for this tan and net, suppose we get some value, that string that looks like this, right? I'm just drawing a bunch of gibberish, but you get the idea. And we will add an entry for tan and net because they both will have the same number of occurrences of characters. And in the end, for bat, we won't have any entry, so we will have a new entry over here, and where we will add the value bat. Now in the end, all we have to do is just iterate over all the values that are present inside this hash map and return it as our answer. And this would be the optimal solution we are going to use. If we see the time and space complexity for this one, the time complexity is actually going to be big O of n times whatever the maximum length of k is. In terms of space complexity, we are actually creating an additional hash map, so that's why that is going to take some additional space. But this is also going to be big O of n times k, where k is the longest length of any given string and n is the number of strings that are present inside the given input. So first of all, we are going to check an edge case, that if the given string is empty, we are going to return an empty array list immediately. Okay, if that is not the case, we are going to initialize our hash map, and we are going to take string as key and list as value. Also, we are going to initialize our array of size 26, and we are going to name it as count. Once that is done, we are going to run a for loop across the given input string. So first of all, we are going to initialize our array with value 0. After doing that, we are going to iterate over this given string s, and we are going to add all the characters inside this given array by adding their value from 0 to 1. After doing that, we are going to initialize a string builder to store the string value that we have retrieved inside this character array. Now we are going to run across the count array, and we are going to add all the values to our string builder. Also at the same time, we are also going to add a hash before all the elements inside this given count array, and that is something per language trick that changes. For Python, you won't have to do it. Once this is done, we are going to assign this new string that we created as a key for our hash map. Now we are going to check that if this entry for this given key already exists inside the hash map. If it does, we are simply going to add whatever the string s that we are iterating over. And if the entry does not exist, we will create one value inside the hash map, and then we will add this value s for this given key. And we are done for this for loop. Now all we will have to do is return all the values from this answer map and return it in the manner that is asked inside this given question. So we will have to return a list of lists. Let's try to run this code. Okay, seems like our solution is working as expected. Let's try to submit this code. And our code works as expected. I'll be posting the solution in the comments so you can check it out from there. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do valid parentheses lead code problem, and this problem has been asked by some of the companies where I want to work at. There are companies like Amazon, LinkedIn, Facebook, Microsoft, Bloomberg, Spotify, Adobe, Google, Apple, Uber, TikTok, Goldman Sachs, Twitter, Netflix, Twitch, Tesla, ByteDance, Lyft, and Airbnb have all asked this question, so that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode easy problem and also one of the most liked problems on LeetCode, and that is because this problem actually solves one of the very real life application where a compiler has to check that whether the code has valid parentheses or not, and so that's why a lot of companies like to ask this problem as an interview question. If we understand the problem, basically we are given a string S that contains just these three types of parentheses: opening parentheses and closing parentheses, and we need to determine that if the given input is actually a valid input or not. We are also given the definition that what counts as a valid input, that if the opening brackets are closed by the same type of closing brackets, and also we are told that the opening brackets must be closed in the correct order. So let's try to understand this with some examples over here. I have drawn a bunch of different potential examples, and we will see that if they are valid or not. So first of all, if we see this example, we know that okay, we have two opening brackets and we have two closing brackets. We can consider this as a valid string, so I'm just noting it as V. Now again, in this case we have two different types of opening brackets and we have two different types of closing brackets, so this is also a valid string. Now in this case, this is an opening bracket, this is an opening bracket, we have corresponding closing brackets. Again we have opening and closing brackets, and again we have opening and closing brackets. So everything is in order and the same kind of brackets are opened and correct in proper shape and size, so we can consider this also as a valid format. Now if we come to this example, this is an opening bracket, this is also an opening bracket, but we only have a closing bracket for this original opening bracket, so we can consider this as invalid option. So we get an idea why it is invalid. In this case we have three opening brackets and only one closing bracket, so again this is an invalid string. And in this case, actually if we see the number of opening brackets and number of closing brackets, they are actually same. So we have one opening bracket and one closing bracket, again one opening bracket and one type of closing bracket, but this is still invalid. Why it is invalid? Because this bracket, this curly bracket, is actually opened before this particular round bracket, so that's why it has to be closed before this round bracket closes. And in this case, this round bracket actually closes first before this curly bracket is being closed. So this is very important property that we will have to keep track of, and that is why we are told that we need to keep track of the order in which they are opened and closed, and then only we can determine that whether they are valid or not. So this is also an invalid formula. So let's see that what would be the potential solution. So let's start from the very simple example and see that what would be the intuition behind building a solution. Suppose we are given an example that looks like this, where we are given all of the brackets that are of the same kind, and we are given some opening brackets and some closing brackets. Well, we can clearly see that this is a valid approach, and how we can determine is that we can actually create a counter. And what this counter does is that at any given moment we identify an opening bracket, we are actually going to increase the value in this counter, and at any given moment if we encounter a closing bracket, we are actually going to decrease the value in this counter. And at the end we have to check that whether the value inside this counter, if that is equal to 0, which means we can determine that the same number of opening bracket and closing brackets are present, and then we can say that the string is actually valid. If that is not the case, we can say it is invalid. So if we see that in action, first of all we have three opening brackets, so we will increment the value of this counter 3 times, and if we do that we will get the counter value to be at 3. Again, now we identify a closing bracket, so now this value from 3 becomes 2. Again we identify two more closing brackets, so again it gets decreased 2 more times, and then we get the final counter value to be 0. And because we get this value as 0, we can say that okay, this string is actually valid string, and the same number of opening and closing brackets are happening. So this is one way to identify a solution, but in this case the complexity is actually very simple. Why? Because we are only using one kind of opening and closing brackets. In our original problem we are actually told that there are three different kinds of opening and closing brackets, and we will have to keep track of them. Also we need to keep track that in what order they were opened and closed, and that order also has to be maintained. So it is not just as simple as keeping track of counter, that we create three different counters for all single type one of them, and then we see that at the end whether this value is 0 or not. We also have to keep track of that what is the order they were opened in and they were closed in. For the optimal solution, we know we need to take care of two things. First thing is we need to check that whether the opening and closing number of brackets are same for each three different types of parentheses or not. Second thing we have to take care is that what is the order in which they are opened and closed. So first let's tackle the first problem. We know that for every single opening bracket there has to be a closing bracket, and they are always in pair. So now to quickly look them up, we are actually going to use a hash map. Now inside our hash map we are actually going to have all of these closing brackets as the keys and their opening brackets as corresponding values. So we are going to have three entries. Now we have to take care of their order and number of occurrences. So the idea is we are actually going to use another data structure called stack, and the stack is actually going to be very helpful to us. So let's try to understand this with an example, that how we are going to use a stack over here. Suppose we are given an input that looks like this. Okay, so I'm going to show you two examples on how we are going to solve this problem. So first let's take this example, and the idea is that at any given moment we identify an open bracket, we are going to add that value inside our stack, and at any moment we are going to encounter a closing bracket, we are going to pop a value on from the stack, and then we are going to see that whatever the value we popped out, if that is the same value that is for any given hash map value we have inside the string for that particular closing bracket. So let's see that in the action. First of all, we identify these three opening brackets, so we are going to add all of the entries inside our stack. So first we will add a curly bracket, then we will add these two brackets. Once we are done with this one, now we have a closing bracket our hand. The moment we identify a closing bracket, remember we will have to pop the value out of our stack. So we are going to pop the value out of the stack, and the value we have popped out is actually this one. Now for this closing bracket, we are going to see that what is the value of that bracket inside our hash map, and the value of that bracket is also like this. And we are going to compare these two elements, that whatever we took out from the stack and whatever we got from this hash map, and both are same. So because both are same, we can say that okay, we are good so far. And now so far we have actually taken care of these four elements, and now we are on this element. Again, this is also a closing bracket, so because this is also a closing bracket, we will have to pop a value out, and we are going, if we pop a value out, we will get a value that looks like this, that we are arrived from our stack. And now we are going to check that for this particular bracket that we were iterating over, what is the corresponding value inside the hash map. So the key is this one, and the corresponding value is this one. So the value we found from our hash map is also this one, and they both are same. So because they both are same, we can say that okay, we are good up until this point. Now we are iterating over this curly bracket, so we again pop, and also I have forgot to delete this value. Now again we pop out a value from our stack, so now we don't have this value over here, and we have a bracket that looks like this. Again, for this closing bracket, the value inside our hash map is also an opening curly bracket, and both are same, so we are good up until this point. Now we are only up to last two characters, so this is also an opening bracket. The moment we identify opening bracket, we will add an entry to our stack, and now this is a closing bracket, so again we will pop this entry out. After popping this entry out, so this is the value we popped out from the stack, and then we will compare from our hash map. So the value is this one, and both are same. So we are at the end of our string, and because we are at the end of our string, we are going to check that whether inside the stack we have any entry or not. We don't have any entry, so we can return true in this case, and we can say that the given string is actually valid, and this would be the answer. Now let's take one more example where the string is not valid, and see that what we are going to encounter in this case. Suppose we are given a string that looks like this. So in this case, we have two opening brackets and one closing bracket. So first of all, we identify that this is the opening bracket. We are going to add an entry over here. Again, we encounter an opening bracket, we are going to add an entry over here. Now we encounter a closing bracket. The moment we encounter a closing bracket, we are actually going to pop out the value from our stack, and the value we popped out is actually a curly opening bracket. Now for this closing bracket, we actually have a corresponding value inside our hash map that looks like this one. Now these two are actually not same, so the moment we identify that these two are not same, we can immediately return that this string is actually invalid, and the parentheses are not in correct order, so we are done with this one. Time complexity is actually going to be big O of n, where the n is not the number of entries present inside the string, and even in terms of space complexity, because we are using a stack and hash map, but we don't care about hash map because it has finite number of entries. But for the stack, the values will be dependent on big O of n as well, on the number of entries present inside the string. Now let's move on to coding. So first of all, we are going to initialize our hash map, and inside the hash map we are going to store the values for 3 different brackets that we are given. Okay, we are done with this one. Now we are going to initialize our stack, and we are going to name it as stack as well. And now we are going to run a for loop across the given string. So first of all, we are going to initialize the character C, and that is to keep track of whatever the character we are looking over inside the given string. Now we are going to check that if the current bracket is opening bracket or closing bracket, which means that if the key value is present inside this mapping bracket, then we can define that it is a closing bracket. If not, then we can define it as an opening bracket. So if the value is not present inside this mapped bracket key, which means that we will have to push the current value inside the stack. If not, which means that the value is actually a closing bracket, and then first of all we are going to pop the value out of our stack, and then we are going to compare it with whatever the value pair inside the map bracket we have. And if the stack is empty, we can return false immediately. So in the else condition, we check that if the stack is empty, we can return false immediately. If not, we are going to pop out a value from the stack, and we are going to name it as top element. And now we are going to check that whether that is the same value that is present for the map bracket value key. And if the values are not same, we can return false immediately as well. And if that is not the case, eventually if we get out of the loop, then we will have to check that whether the given stack is empty or not. If the stack is empty, we can return true, or else we can return false. Let's try to run this code. Okay, seems like our code is working as expected. Let's submit the code. And our solution is actually pretty fast compared to a lot of other solutions. So I would be posting this in the comments so you can check it out from there. Thank you. Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do valid palindrome lead code problem, and if we see some of the companies where I want to work at who has already asked this question, there are companies like Facebook, Amazon, Microsoft, Apple, Bloomberg, Spotify, Adobe, TikTok, Google, and Uber. So that's why I am paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode easy problem, and basically we are given the definition of what a palindrome is. We are told that after converting all the uppercase letters into lowercase letters and removing all the non-alphanumeric characters, if the string reads same as forward and backward, then we can determine that any given string is a palindrome. Now we are given a string s, and we need to return true if the given string is palindrome. If not, we need to return false. So let's try to understand this with an example. Over here we are given a string that looks like this, where you can see that there are some alphanumeric characters as well, which we will have to get rid of. This is only put there just to add some sort of additional complexity. Apart from that, it serves no purpose. This is the original string that we are given. Now if we convert all the uppercase letters to lowercase and remove all the alphanumeric characters, we will actually get a string that looks like this. And if we see for this particular string, if we start going from the front and even going from the back, we will see that all the characters that are present from the front, they are also present from the back in the same order. So that is why we can determine that this string is actually a palindrome, and we will return true in this case. We are given another example that looks like this. Over here we can also see that there are some alphanumeric characters which are the 2 space values, so we will have a string that looks like this. And over here, if we try to see that whether this is a palindrome or not, currently this R matches, A matches, C matches, but this E actually does not match over here, and over here actually we have an A. So that's why this is not a palindrome, and we will return false in this case. So let's see that what would be the approach to solve this problem. Now suppose this is the example that we are given, and we need to determine that whether this given string is a palindrome or not. The approach I'm suggesting is, first of all, we iterate over this given string, we get rid of all of these characters that are alphanumeric. Once we do that, then we will create a new string that is actually reverse of this original given string. And now we have two strings at our disposal. All we have to do is compare both the strings. If they are same, we can determine that they are actually palindrome and we can return true. If they are not the same, we can return false immediately. So let's see that in the action. So first of all, we are going to create a string from this original input string where we are going to get rid of all of the non-alphanumeric characters. Once we are done that, now we are going to reverse the string. So we are going to create a new reverse string from this original given string, and we are basically reversing whatever this given input is. In this case, if we compare this given reverse string and whatever the string we are given, they both possess the same value, which means we can determine that this given original input is actually a palindrome and we can return true in this case. So this is one of the solutions where we can work with, and this solution would work as expected, no issues with that. Let's see that what would be the time and space complexity over here. So for the time complexity, actually, first of all, we are iterating over this given string to remove all of the alphanumeric characters, and then again we are iterating over this given string to create a new reverse string, which means that we are essentially iterating over this original string 2-3 times and comparing it, and basically we are doing big O of n work, but actually we are doing like big O of 2 times n work. In terms of space complexity, because we are creating this new original reverse string, so that is why we are also consuming some space. So that's why the space complexity in this case is also going to be big O of n, where n is the number of characters that is present inside this given string. So this approach is okay, it's justified, it works as expected, but the question is, can we do something better in terms of space complexity and even in terms of time complexity? And yes, there is a better approach, and let me quickly show you how. Okay, so for the optimal solution, what we are going to do is, suppose we are given an input that looks like this. Now over here we are actually going to use a 2-pointer solution, and we are going to have a left pointer and a right pointer, and initially the left pointer is going to be located at the leftmost position and right pointer is going to be located at the end of our string. Now at any given moment we are going to compare that what is the character value of left and right pointer, and we are also going to check that whether this given left and right pointer, if there is that like a non-alpha numeric value. If that is the case, we will just like increase the value of left or right pointer, and if both the values are same, essentially we will move the left pointer on the right side and we will move right pointer on the left side, and we would keep on doing this process until left and right are adjacent to each other before right crosses the left. And if we are able to reach to that point, we can determine that this is actually a true and valid palindrome. If that is not the case, we will basically return false at any given moment if we identify that left pointer and right pointer character values are not matching up. So let's see that in action. Suppose this is the string we are given. Currently the left is located at this m and right is located at this small m, but in both the cases we are only dealing with lowercase English letter. So even if we encounter an uppercase English letter, we would convert it to lowercase English letter. We would treat it like this. So this m is equal to m. So far we are good, which means we will have to update the value of left and right pointer. So now this left pointer is going to go to the next value, which is over here, and this right pointer is going to go to a previous value, which is over here. Now at this position right, we actually identify that this is not an alphabet, so we would again update the value of right pointer and we would ignore this case, and this time right pointer comes over here. Now because both of these are valid alphanumeric value, we will try to see that what are their values, and both are located AA, which means they are same. So if they are same, again we are good up until this point. Again we will update the value of left and right pointer. So now left pointer is at D and right pointer is actually located at this column over here. So because this is not an alphanumeric value, again we are going to ignore this and we are going to update the value for right pointer. So now right pointer would end up at the same position where left pointer is. If we again compare the value, both are going to be DD. So again we are good up until this point. Now we don't have to do it, but because in our algorithm we are specifying that we need to check before right pointer crosses the left, and in this if we do one more iteration, essentially right would come and left would come over here, which means that they would be crossing each other, and which is not what we want. So we have already concluded that all the characters inside this given string, they are actually part of a palindrome, and we can return true in this case. And this is the approach we are going to take. Now if we see the time complexity in this case, the time complexity is actually going to be big O of n only, because we are completing everything in just single iteration. We are having our left pointer move to the right side, and we are having our right pointer move to the left side, and we stop when they meet. Now in terms of space complexity, we are actually doing it pretty efficiently. We are only using couple of pointers to store in our space, so that's why it's only a constant space that we are consuming. And this approach is much better approach, and we will conclude this as to be an optimal solution. Now let's move on to coding. First of all, we are going to initialize couple of variables called left and right, and we are going to assign the left to be value 0 and right to be value to the end of the string. So now we are going to run a loop that while left is less than right. So now first of all, we are going to check that if the current value on the left side, if that is not alphanumeric, we will have to update the value of left pointer. Same thing we are going to do with the right pointer, but we are actually going to reduce the value for the right pointer. And if we identify that both left and right are correct letters, we are going to check their values. And if they are not same, we can return false immediately. If they are same, we will continue updating the loop. So if that is the case, if the characters are not matching after converting them to lowercase, we can return false immediately. And if that is not the case, we would update the values of left and right pointer. And once this loop ends, essentially if we get out of the loop without returning false, we can simply return true. Now let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code is actually pretty efficient. I would be posting this in the comments so you can check it out from there. Thank you. Hello friends, we are not employed by a FAANG company, so let's not stop LeetCode until we get there. Today we are going to do longest palindromic substring LeetCode problem. And if we see some of the companies where I want to get a job who have already asked this question, there are companies like Amazon, Microsoft, Google, Adobe, Apple, Bloomberg, Goldman Sachs, TikTok, Uber, ByteDance, LinkedIn, Tesla, and eBay. So that's why I'm paying my utmost attention. I hope you also enjoy the video. This is a LeetCode medium problem and also one of the very well-liked problems on LeetCode. Basically, we are given a string S and we need to return the longest palindromic substring that is present inside this original given string S. So in order to understand this problem, first of all, we'll have to identify that what is a palindromic string. And a palindromic string is basically, as the name suggests, any string that forms a palindrome. And we know that palindrome is any string where if you read it from left to right or right to left, the number of sequencing is same. So in this case, ABA is actually an example of a palindromic string. Also ABBA is also an example of palindromic string, because in either of these two cases, whatever side you decide to move along, the number of character occurrences remains the same. So that's why they are palindrome. And now our aim is to find the longest palindromic substring inside this given original string S. This is not a very good example to understand, so let me create a custom example. In this case, we need to find that what is the longest palindromic substring. So if we see the string S by itself, it's actually not a palindrome. But if we see these three values A, B, A, and we get rid of this B and D, we can actually create a palindrome, which means in this case, we can return the answer as A, B, A to be longest palindromic substring that is present inside this given string S. And this is exactly what we need to return. So now let's see that what would be the different approaches to solve this problem. In order to understand the brute force way, we'll have to identify that what is the thing we need. We need the longest palindromic substring that is present inside this original given string S. So the aim is that we need to find a substring. So why don't we just use the brute force method and we find every single possible substring that we can make out of this given example S. So we can make bunch of different substrings. Let me just draw some substrings over here. So these are some of the substrings that we are able to generate from this original given string s. Now our aim is to find that what is the palindromic substring. If the substring is palindromic, we will find its length and then we will try to find the longest palindromic substring in that way. So we can clearly see that in this case, this ABA is going to be the answer for this longest palindromic substring, and eventually we would be able to find the solution using the brute force method. But what is the issue with this? Like, issue is actually pretty evident that even for this 4-character string, we actually had to create bunch of different substrings, and out of all of those substrings, we will have to find some effort and resources to find that what is the longest palindromic substring. So that is just waste of time and energy. If we see the time complexity, in this case the time complexity is actually going to be big O of n cube. Why m cube? Because it takes n square time just to create these substrings, and after doing that we will also have to identify that whether those given strings are actually palindromic substrings or not, and which is the longest amongst all of them. So that also takes n time. So that's why the overall we can write it as big O of n cube time complexity. So let's see that what would be the better approach to solve this problem. Well, before we come to the optimal solution, first let's build some intuition behind achieving that optimal solution. The idea is that we need to find the longest palindromic substring. Now there are two possibilities. We could have an odd number of string that is a palindrome, or we could have an even number of string that is actually a palindrome. Now in each cases, the middle value is actually providing some interesting results. And the thing is that in both the cases, the palindromes are actually built around these middle values. How? Let me quickly show it to you. Well, if we just take this madam for an example, over here we can actually conclude this D to be a substring in its own, and because this is a single character substring, we can actually conclude this to be a palindrome as well, because if we read from this left direction or right direction, in each cases we are going to get the same result. Now if we add these two A's to this D, we will also get the substring that looks like this A, D, A. Now in each cases this D remains common, but the left value and the right value, because they both are same, we can conclude this string to be a palindrome as well. Now again, if we repeat the same process and we add this M and M, again because they both are same and we are adding at the corners, so if we add them, we will get a value that looks like this. Now this D originally was a palindrome. After adding this AA, it remained palindrome because both character had the same value. And again after adding this MM, again the whole thing remained the palindrome because they both had the same value. Now in this case, if I extend and if I add a value that looks like X and Y over here, so this X and Y is actually not same. So this whole thing will not be a palindrome, but this middle portion will actually be a palindrome. And in this case, because we had odd number of characters that are forming a character, we actually have just one value that we can consider as middle value, and all the other values from this middle value are actually just a bunch of set of characters who both have same values. Let's take an example for this even number case. Now in this case, actually we have two middle values, and the two middle values are BB. Now if we were to consider this BB, this is actually a palindrome in itself, because again by definition, even if we go from left or right, in each cases we are reading the same value. Now again this AA, both are same value and they are actually same value that corners our original given middle values. So if we form a value that looks like this BB was already a palindrome, and the two values we added, they are also same. So because they are same, this whole thing actually becomes a palindrome. And again, just like this case, if we add an X and Y over here, this whole thing will not be a palindrome, only this ABBA would remain palindrome. So now after knowing this solution, actually it becomes really easy for us to identify that what would be the optimal solution. Suppose this is the example that we are given and we are trying to find the optimal solution for that. So what we are going to do is we are actually going to expand on the corners, and we are trying to see that whether the left and right value of any middle value, if they are actually same or not. If they are same, we can consider the whole part to be part of any palindrome. If they are not same, then we will move on to the next value and start doing the same process. Now there could be two possibilities. We could have an odd length palindrome where we will only have one middle value, or we could have an even length palindrome where we will actually have two middle values. So in each cases we will have to take care of them. So I'll be showing you the odd example first, and then I'll show you the even example. And basically it's slightly different idea, and I'll just show you when we go there. So first of all, we are going to take this value X. Now we are going to expand upon the corners. So we are going to see that whether this X could be the middle of a longest palindromic substring. If that is the case, then we will expand upon this x. So we will try to see its left value and right value. The left value is actually null and right value is actually m. Now this left and right, they are not same, and also this middle value is actually not same with this right value, and it's also not same with this left value, which means in each cases this x is actually not part of the middle of longest palindromic substring. So we will get rid of it and we will move on to the next value. Now we are at this value number m. Again we try to see the what is the left and right value. Left is actually x, right is actually a. Again they both are not same and none of them are same with this m, so which means that now we will move on to the next value. Next value is actually a. Again the left value is m, right value is d, nothing is same, so we will move on to the next value because this is also not a part of the palindrome. Now we are at this position number d. Now if we take the left and right value, the left value is actually a and the right value is also actually a. So because this left and right value is same, this d could be a middle of any palindrome. We don't know if it is the longest palindromic substring or not. Now the longest palindromic substring that we have found so far is actually of length 1. Why length 1? Because any character in itself is also a palindrome, remember that. So that's why now we have this new substring that looks like this a b a. This is also a palindrome, and we will try to see that whether it is longer than whatever the existing palindrome we have, which is true that this a b a is actually longer. So we will have to update the value of this a b over here, saying that this is the longest palindrome we have found so far. We will keep on expanding on its corner. So far the values we have is a b a. Again we will move on a left and right pointer. So this is m and this is also m. So because they both are same, again we can consider this to be a palindrome. And the previous longest palindromic substring we had was ABA, but this is actually greater than that, so we'll update its value. And now the longest palindromic substring we have found so far is MADAM, MADAM. Now again we will go and repeat the same process. Over here we will have the value y and over here we will have the value x. So these two are not same. So because these two are not same, now we are no longer forming a palindrome. So we will have to get out of it. So we will just move on to the next value. And if we move on to the next value is actually a. So again this a, the left value is d and right value is m. So this is not a palindrome. We will go back to m. M is also not part of any middle of any palindrome, and this y is also not part of any middle of the palindrome. So now we are done for our example so far. And in this case, whatever the answer we have found over here for the longest palindromic substring, which is MADAM, we will return this as our answer, and this solution would work as expected. Now this was the case of odd number of palindrome that is being the longest. Let's see the even number of palindrome. So in this case, again we are going to repeat the same process. First of all, we'll take this x, we take the left and right value. Again we don't find anything interesting, so we'll move on to the next value. Now next value is a. Again we check left and again we check right. We don't find anything, right? So we'll move on to the next value. Now again we are at this position number b. Now we are at this position number b. If we check the left value, we find a, but if we check the right value, we actually find another b. So because these two are same, actually the combination of these two b's could be the middle of the longest palindromic substring, and that is going to be true in this case. So we are going to expand on a little bit differently now. Now we are going to have this bb as the middle of the longest palindromic substring we have found so far, and we will repeat the same process. So we will try to find that what are the left and right values. So left value is a and right value is also a. So again this is a b b a, because these two are same, and this middle portion we are just consider it to be the middle. So this is also forming a palindrome, and the longest palindromic substring we had so far was only of length 1, and then when we found this bb, it become of length 2, and now we have this ABBA. So this is of length 4. So because this is of length 4, we will have to update the longest palindromic substring we have found so far to be ABBA. Now again we will repeat the same process. So if we again go left and right, this is actually x and this is y. So now these two are not same. Because these two are not same, so now we will just get out of it. We will again check with this a and y. We don't find any palindrome, and we would be done with this one. So in this case, we would return this ABBA as part of our answer, and that would be the final solution. So the time complexity in this case is actually going to be big O of n square. Now why n square? Because we will have to iterate over every single value to see that whether that is the middle of the longest palindromic substring or not. That takes n time, and if we will have to iterate over all the values on the left and right side to see that whether it's the longest palindromic substring or not, which which means that in the worst case scenario, we might have to iterate over n square times to find the answer. In terms of space complexity, we might have to keep track of big of n characters at any given moment, where n is the number of characters present inside the string. Now this is actually a much bigger improvement compared to our brute force approach, which had the time complexity of big of n cube actually. And now let's move on to the coding. First of all, we are going to check some edge cases. If that is not the case, we are going to run a for loop across the given string. For the any value we are iterating over, we don't know that whether it is the middle of the longest palindromic substring of an even length or of an odd length. So at any given time, we are actually going to have two variables that call a function where we are going to check that whether the odd length or even length palindromic substring can it be the middle of any palindrome. And so first I'll create two variables and we'll name it as len1 and len2. And we are going to call a function called check palindrome. Inside this function, we are going to provide the value of given string s, current position of I, and we are considering this to be an odd length, so that's why we are considering I to be the middle element. Also, we are going to create a variable called length2. We are again going to call the check palindrome function. We are providing the value of string s, we are also providing the value of I, and we are also providing the value of I plus 1. Why plus 1? Because remember that in the even length palindrome we actually have two middle entries, and that is how we are going to do it. And also we are going to have a variable called length where we are going to keep track of the maximum length of palindrome we have found so far. Remember that amongst these len1 and len2, at any given moment, if we identify that there exists some valid palindrome and we have found the maximum value, we might have to update the value of the maximum variable. So we are going to check for that condition as well. For that, we actually need two pointers called left and right, and we are going to check that whether the given length we are getting, if that is greater than the left and right length we have already found so far. The thing is, we haven't declared these variables yet. So first of all, let me quickly declare these variables, and we are going to initialize their values as 0. We are going to update the value of the left pointer, and that will be decided based on the value of I. So we are going to do I minus whatever the value of current length we have found. We need to do it divide by 2. The thing is, we don't know that whether that length is odd or even, so we will subtract it by one value and then we will divide it by 2. So in any case, we will get the correct result for the left pointer. And for the right pointer, we are actually going to do I plus whatever the length we have found divided by 2, and this should give us left and right pointer to create the desired substring. And after we run out of the loop, we will simply return the substring. So now we are done with most of the logic in the main method. Now we'll just have to create this check palindrome method. So let's assign the value L and R for the ease of our use. Now we are going to run a while loop that until the point when we have a valid palindrome, we will keep on reducing the value of left and updating the value of right, and we will check that whether both values are same or not. We'll also take care of some edge cases. While the existing value is a valid palindrome, we will reduce the value of left pointer and we will update the value of right pointer. This while loop, we will return the whatever the length we have found so far. This should do it. Let's try to run this code. We will have to update the value of this right pointer by 1. Let's try to run the code again. Okay, seems like our solution is working. Let's submit the code. And our code works as expected. I would be posting this in the comments so you can check it out from there. Thank you. Hello friends, we are not employed by a FAANG company, so let's not stop LeetCoding till we get there. Today we are going to do Palindromic Substrings LeetCode problem, and if we see some of the companies where I want to get a job who have already asked this question, there are companies like Facebook, Amazon, Twitter, Google, Microsoft, Uber, Goldman Sachs, Apple, Bloomberg, and LinkedIn. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem, and basically we are given a string s and we need to return the number of palindromic substrings that exist inside this given string s. Lucky for us, we are given the definition that what a palindrome is. Basically a palindrome is a string that reads the same from backwards and frontwards. So suppose we are given a string like this GG. If we read it from the backwards or frontwards, in both the cases the answer remains the same. Also one more example, ABA. This is also an example of palindrome because in either case we read it, the answer remains the same. Now a quick question for you guys, that whether this character B, is this an example of a palindrome or not? And the answer is yes, this is also a palindrome. Why? Because if we read it from the left and also read it from the right, we get the same result. But if we are given a string that looks like this AB, this is not a palindrome because if we read it from the left and from the right, the answer is not the same. So these are some of the examples of a palindrome. We are also given the definition of a substring, but I don't think that it is necessary to define. It is actually pretty trivial. Now let's try to understand this problem with an example. Suppose we are given a string S that looks like this CABA. Now in this case, we need to find that what are the number of palindromic substrings that exist. So we can clearly see that we have a palindromic substring that are these four characters are actually palindrome in itself, because as I mentioned earlier over here, that even a single character is also a palindrome in itself. So we already have four palindromic substrings so far. But if we notice over here, we also have one more palindrome, that is this ABA, and that is also a palindromic substrings, which means that in this case we need to return 5 as our answer, that we can actually make 5 palindromic substrings for this given string S, and this is what we need to return. So let's see that what would be the different approaches to solve this problem. Suppose this is the S we are given and we need to find that what would be the brute force solution for this problem. Well, we have to understand that we need to find all the existing palindromic substrings that are present inside this given string S, which means we need to find the substrings. So what we can do is we will make all the possible substrings that we can make from this given S, and then we will check that whether that substring is a palindrome or not, and simply we will get our desired answer. So if we see that in action, for this particular string, we can actually make substrings that looks like these. So these are all the substrings that we can make from this given string S. Now all we have to do is check that whether any given string is a palindrome or not, and in this case we will find that these four strings are palindromes, and also this string is a palindrome. All the other strings are not palindromes, and then in the end we can return 5 as the answer for this problem, and that would be a valid answer for this problem. But what is the issue with the brute force approach? Well, the issue with the brute force approach is that the time complexity in this case is actually going to be big O of n cube. Why n cube? Because it takes n square time just to make these substrings, and then it takes n time to check whether a substring is a palindrome or not. So cumulatively this is a very bad time complexity, and we will have to find a better approach. So before we move for the optimal solution, first of all, we will have to build some intuition behind it, that how to identify a palindrome. Well, in the palindrome, there could be two possibilities. The palindrome could be of odd length or it could be of even length. First, let's see that what would be the scenario in the odd length. So suppose we are given this character O. This is a palindrome in itself. We have already identified that, because if we read it from left or right, we get the same result, right? Now, if I decide to add two more characters, XO, XX at the edges, this still remains the palindrome, which means that because both of these x's were same and this middle value was a palindrome in itself, this whole thing actually became a palindrome. Again, if I take it even further, if I add two more characters BB, again this whole thing still remains a palindrome. And if I keep on adding same values, as long as they are same, this will always remain the palindrome. But the moment I add a value that likes A and B, now this whole thing is not a palindrome because these two values are different. But this portion is still a palindrome, and also the smaller portion still remains the palindrome, which means we can define that the palindromes are like an onion, where the middle value remains the same, and because of the middle values, all the other subsequent values where the values are actually same, the palindromic property is sustained. Why I'm giving so much explanation for that is you will see it in the optimal solution. And in the odd cases, we only have one value as the middle character, but inside the even character, suppose we are given a value like BB. So this is a palindrome in itself, and both values are same. Because both values are same, this is an even length and this is an even length palindrome. Now again I decide to add two more characters XX. Because they both are same, this still remains the palindrome. Again I add value AA, this is also a palindrome. But the moment I add a value that is different like X and Y, now this whole thing is not a palindrome. But this middle portion still remains a palindrome. So that is the important property, that in case of odd length, we have a middle character of the palindrome that is a single character, and all the other characters has the same value. In case of the even length palindrome, we have two characters that are same. So that is important, two characters, they are both same, and then all the other characters, they are also same as well, and a smaller palindrome is forming a larger palindrome. And let's see that how can we use this property to find an optimal solution. So suppose this is the example we are given, and we need to find the optimal solution for that. The idea is that at any given character, we are actually going to see that whether could this be a middle of any palindrome, and if it is the middle of the palindrome, we are going to keep on expanding our palindromic search, and we are going to keep adding our answer result. First of all, let's see for this character number C, that can this C be part of any middle of the palindromic substring or not. Well, we already know that this C is a substring in itself, because if we read it from left or right, we get the same result. And we are also going to have a variable called answer, so initial value was 0. Now because the C is a palindrome in itself, we are going to add the value to our answer as well. Now we are going to see that whether the C is a middle of the palindrome or not, which is not. Why? Because if we see the left of the string and right of the C, this is actually a null value and this is A, which means both are not same. So because both are not same, this is not part of any middle of the substring. Now we are going to have this value A. Again, we are going to repeat the same process. Well, A is a palindrome in itself. So we are going to add the value to our answer first of all. So this becomes 2. Now again, we are going to check that whether this A is the middle of any palindrome or not. We also have to check for both the cases that could this be of odd length palindrome or an even length palindrome. So for odd length palindrome, like the both left and right value would be same, and for even length palindrome, the value would be same with that itself. So first of all, we are going to check with this A. So the left value is C and right value is actually B. So both are not same. Also, they are not same of this A and B, which means this is not an odd length palindrome and even length palindrome. So we are good to go. Now we will move on to the next value B. Now this next value B is a palindrome in itself. So we will update the value inside our answer to 3. After doing that, we are going to check that could this be the middle of any palindrome or not. So we will check the left and right value. Left value is A and right value is also A. So because these two are same, we can define that this B is actually part of the middle of the palindrome, which is of odd length, and we are going to keep on expanding our palindrome. So now this B, A, B, so sorry, now this ABA is also a palindrome, so we will update our answer immediately. So answer becomes 4 now. Now again, we will keep on expanding our palindrome. So if we do a left and right over here, the left value is C and right value is actually null. So these two are not same. Because these two are not same, we no longer have a palindrome, so we will break out of the loop. Now again, we still have one more character left to check. So again, we will check for this value number A. So A is a palindrome in itself. We will put the answer as 5. Then again, we will check that whether this A is that a middle of any palindromic string or not. So we check left and right value. Left value is B and right value is actually null, which means these two are not same and they're not same of this A as well. So immediately we will break out of the loop and we can return, and the next value over here is actually null, which means we don't have anything. We have reached to the end of the string. So this is the answer we need to return in this case, that the 5 would be the answer, and we will return that. Let's see one more example S, where we will find the even length palindrome. So over here again, we are going to repeat the same process. So first of all, we'll take this character number C. Can this C be part of any middle of the substring or not? So this is not part of any middle of the substring, and we will have an answer variable. So first of all, we'll initialize it to 1 because C is a substring in itself. Now we'll move on to the next value A. So A, where A, if we check the left and right pointer, left is C and right is B. So these two are not same. So immediately A is also not the middle of any new palindrome, but it is a palindrome in itself. So again, we will update the value to 2. Now again, we are at this position number B. Now at this position number B, if we compare left and right values, so left value is A and right value is B. So these two are not same, but these two are actually same. So we can define this BB to be a middle of a palindrome, and this is the property we are going to use, right? And by the way, for this B, first of all, we'll update the value to 3, and now we have this BB, that is a middle of the palindrome. Now immediately we will check the left and right value. So left value is A, right value is also A. Again, these two are same, so this is also palindrome, so we'll update our answer again. So this becomes 4. Now again, we will check the left and right value over here. So left value is C and right value is actually null. So in this case, these two are not same. Because these two are not same, we will break out of the loop and we will say that okay, so far we have found something decent. So right now again, we are at this position number B. Now remember that this becomes a little bit tricky, that it becomes easy for us to, if we check over here, this left value is actually b and right value is a. So again these two are same, but we should not fall for this trap because we have already concluded this bb to be a middle of the palindrome, so we will not consider this one. And this is also not a palindrome, which means that the answer we will only update by one, and that this value by itself is a palindrome. And at the end we will check for this value number a, and a is a palindrome in itself, so we'll update the value to be 6. But in the left and right there is nothing, so we won't do anything with that. And in the end we will return this answer 6 to be the final answer. And this is the solution we are going to use to find all the palindromic substrings inside any given string s. This is the final optimal solution. If we see the time and space complexity, in this case the time complexity is actually going to be big O of n square. Why n square? Because it takes us n time to iterate over all the values, and for any single value we might have to iterate over all the remaining values, so that takes n square time. But this is still a big improvement compared to our brute force approach, which had the n cube. If we see the space complexity, in this case the space complexity is actually going to be big O of n, because at any given point we might have to store all the values of n. First of all, we are going to initialize a variable called answer, and we are going to assign the value as 0. Now we are going to create a for loop and iterate over the given input. Now we have two possibilities. Any single character inside this given string s could be the middle value of any odd length palindrome or an even length palindrome. So we are actually going to make two calls to our check palindrome method, where we are going to return a value that whether this given string is a palindrome or not, and we are going to add that value to our answer variable. And inside this method we are going to pass the value of our string s, and we are also going to pass the character position of the middle variable. So the odd length palindrome would have the same middle value, so we will pass on that. And for even length we are going to pass two values. So over here we will pass I, and we will also pass I plus 1 to be the middle characters. Basically after we get out of this loop, we should have our answer ready, so we can simply return that. Now let's create this check palindrome method, and we will initialize a variable called count to count the number of palindromes we encounter. Now we are going to run a while loop, that while the left and right pointer are in bounds and not out of bounds, and while their character positions are same, so which means they satisfy to be the palindrome. If that is the case, we will keep on updating their values, and we will keep on adding our count variable, and in the end we will return the count variable. So let me quickly type that. So this condition defines that whether this given string is a valid palindrome or not. If that is the case, we will decrement the value of our left pointer, we will increment the value of our right pointer, and we will increment the value of our count variable. And once that is done, once we get out of this loop, we simply need to return the count variable, and that's it. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty efficiently, and I would be posting this solution in the comments, so you can check it out from there. Thank you. So the LeetCode problem we are going to solve today is called palindrome linked list, and this is a LeetCode easy problem and also extremely well-liked problem on LeetCode. Problem statement is very simple. We are given the head of a single linked list, and we need to check that if this given linked list is palindrome or not. If it is palindrome, we need to return true. If it is not palindrome, we need to return false. So this is one of the examples where we are only given the head of this linked list, and then we need to iterate over all of these values. After iterating over, we need to essentially determine that whether this is a palindrome or not. So in this case, we can see that since this first two portion and last two portion are same in the reverse order, it is a palindrome. So in this case, we will need to return true. Suppose we were given a linked list like this, where values are 1, 2, and then once again 3. So in this case, this is not a palindrome. But in this scenario, instead of this being 3, if we had value as 1, then this would have become a palindrome, and we need to return this one. So the problem statement is very simple to understand, but there are a couple of nuances with this problem. So number one problem is that we are only given singly linked list. That is one part. Second thing is we don't know that how many number of total values are inside the given linked list because we are only given the head of the linked list. So that is the second problem. Third problem is that in order to determine that whether anything is a palindrome or not, we essentially need to break this existing linked list into two portions and determine that whether it satisfies the property of a palindrome or not. So if it is an even numbered palindrome or even numbered linked list, then both the halves would be of the same value. If it is odd number, then either this middle value could be shared, or we can create a palindrome or compare just these two sizes of the palindrome. But in either case, we will need to find the middle pointer for each of the odd or even number of cases, and then compare the first half with the second half. So this is going to be our approach towards the solution. Number one thing we are going to do is to find the middle of the existing singly linked list. Second thing is that we are going to compare two portions, the first part and the second part, and then we are going to come up with the solution. So first, let's determine that how can we define or find the middle of any singly linked list. For that, we have a very simple method, that is to use the two pointers, and first pointer is going to be a fast pointer and second pointer is going to be a slow pointer. The logic is quite simple, that at every single iteration, slow pointer is going to go to its next element and fast pointer is going to go to the next of the next element. So which means that fast pointer is going to make two hops and slow pointer is going to make one hop. The moment we identify that fast pointer has reached to the end of the list, or fast.next value is at the end of the list, then whatever the position of slow pointer is has to be the middle pointer of any linked list. So let's see this theory in action. First of all, suppose we are given a linked list with let's assume 5 values for now, and currently these values are just simple sequential order, right? This is not a palindrome, we can clearly see that, but we are trying to find the middle point. So we are going to have two pointers, fast and slow pointer. Both are going to initially start at the very first position. So during the first round of iteration, okay, so fast and slow are starting at the same position. During the first round of iteration, fast pointer is going to make two jumps, so fast pointer would end up over here. Meanwhile, slow pointer would only make one jump, so slow pointer would end up at the second location. In the next iteration, once again fast pointer is going to reach to the very end of the linked list, or in this case, because it will reach to the fifth position. Meanwhile, slow pointer would once again end up after just one single iteration over here. Now notice that currently fast.next is actually the null value or the end of the linked list, which means currently this fast pointer is at the very last element of our existing linked list. So whatever the position of slow pointer is has to be the middle pointer. And in this case, based on the number of hops we take from starting to end, we can determine that whether this value is odd value linked list or even value linked list. And based on that, we can determine that which middle portion we will need to check. So now we have a linked list with 1, 2, 3, 4 and 5. We identify that this 3 is the middle pointer, which means in order to check that whether this is a palindrome or not, we will need to compare these two items and we will need to compare these two items. That is number one option. So what are the ways for us to do that? Now, number one thing is that let's say that if this were to be a palindrome, let's assume that instead of this being 4 and 5, suppose these values were 2 and 1. If this was a correct palindrome, the approach would be when we compare the first and second value, and when we go in the reverse order for second and first value, the value should have been same. So if we try to compare this value with this value, we should get the same result. If we compare this value with this value, once again we should get the same result, which means we are comparing in the reverse order. Now, which data structure allows us to fetch the last entered element at the very beginning? And the answer is quite simple, that is stack, because we know the logic of stack is that it works on the last in first out principle. And in this case, we only need to check that what was the last value we put in and what was the first value we put out, so we can start comparing these two values end to end and then come up with the simple solution. But this is not the optimal solution, but this is a way to get to the optimal solution. So the logic is that first, what I'm suggesting is that we have an empty stack, and currently in the empty stack, whenever we are iterating over these values in sequential manner, because slow pointer is going to go through all of the values. Okay, So all the values that are currently placed in the slow pointer, we are also going to add it into the stack, and fast pointer is going to lead us to the very end of the linked list. And then once we find the middle portion, we will have this first portion of the linked list inside the stack, and our start pointer would be at the middle portion. So we will have a way to iterate over all the remaining values inside the existing linked list, and then we will simply pop one value out from the stack and compare that value with our linked list. So let me clean this up a bit, and once again just re-explain the whole solution that I just suggested using the stack and linked list. So number one thing is, suppose our linked list is 1 2 3, and then let me add one more value, okay, and then 3 2 1. Okay, suppose this is our linked list is like this, and currently our stack is empty. Now let's start iterating over using our 2 pointers. So if we do that, basically currently fast pointer is going to be here, slow pointer is going to be here. In the next iteration, fast pointer is going to end up over here, slow pointer is going to end up over here. In the next iteration, fast pointer is going to end up over here, meanwhile slow pointer is going to end up over here. And finally fast pointer, when it reaches to the end, slow pointer is going to reach to the value number 4. So far slow pointer has taken journey from 1 to 2 to 3 to 4, and it realized that this is the middle pointer. We also identify that this is an odd number linked list, which means this middle portion either we consider it 2 times or we don't consider it. So we have both the options. Depending on whatever programmatical approach we want to go, we can go with that. So our algorithm is that all the values inside the slow pointer, we are going to add it into the stack, and we are going to add it into the, once again based on the property of the stack, that is last in first out. So we are going to have value number 1, then value number 2, then value number 3, and in the end value number 4. Or we can, if you choose, you can also not have value number 4. So let's not have value number 4 for the simplicity's sake. Now our starting pointer is slow pointer is here. Remaining portion we need to compare. So what we can do is, with every iteration we make on the slow pointer, we simply pop one value out of the stack. If both values are same, because logically if they are palindrome, then both values has to be the same. If both values tend to remain same and we reach to the end of the linked list, then we can say that this is a true palindromic linked list. So logically, once again in this case, so first we move to the next value, we find value number 3, we pop one value out, once again value number is 3. So because both are same, we can ignore these two. Now once again we move forward to the next case. So next value is value number 2. Once again when we pop out, we also get value number 2, which means this is also good. And in the end, this is 1 and this is 1. So this is also good. We reach to the end of the linked list, which means this is a palindromic linked list. So we can return true in this case, that this given singly linked list is a palindrome, which is quite awesome. Now come back to our question, and let's try to analyze the time and space complexity in this case. The time complexity is actually quite simple. It's simply big O of n, because notice our slow pointer is simply iterating over all the characters in order for us to determine that whether this is a palindrome or not. And this is the best we can do. We cannot go any faster than this. It has to be big O of n, because in order to check for palindrome, we will have to check every single node inside the linked list. But in order to check for the space complexity, now in this case, because we are using an extra space, our space complexity is going to be big O of n divided by 2, because we are only populating the stack up to the half pointer of any given linked list. So this logic would work fine, and this solution would also work as expected. But let's think, is there a way we can improve upon this solution? And the answer is yes, quite simple. That is the improvement we can make on the space complexity. The question is, do we really need to check for the stack, or is there some other way we can actually avoid using the stack and still iterate over these values and compare these values whether they are same or not? So the answer is actually quite simple. The logic this time we are going to use is that we are actually going to use 2 pointers. So we already defined that we are going to be using 2 pointers to find the middle of the linked list. So let's assume that we find the middle of the linked list as the slow pointer. Now we have these values 1, 2 and 3 over here, and these values as 3, 2 and 1 in the reverse order. If that is the case, then only this is a palindrome. So what logic we are going to use is that at every given moment we will actually have to manipulate these nodes to point to in the reverse order when we are finding the middle pointer as well. And there is a very popular algorithm for that, that is reversing the linked list. In this case, we will actually have to manipulate this existing linked list for a bit. So how it would happen is that initially, suppose this is the linked list we are given. Now, the moment we are trying to find the middle pointer, that is this slow pointer that is reaching to the middle pointer, we are actually going to manipulate our list. So currently the list is 1 is pointing towards 2, 2 is pointing towards 3, and then 3 is pointing towards our middle value. Let's assume this is 5. And then this is pointing towards 3, 2 and 1 in this fashion. So logically, when our slow pointer moves from 1 to 2, instead of like only updating, we are also going to update this 2 to point back to the 1 instead of pointing to the 3. This would be called, basically we are manipulating the input for our simplicity's purpose, because we are trying to optimize our solution in terms of space complexity. So now we are going to have a linked list that looks like this, where currently this is pointing towards this. Then 3 is pointing towards this middle pointer 5, where currently our middle pointer rises, where our slow pointer is. And then 5 points back towards 3, and then once again 2, and then once again 1. And using this logic, we can actually traverse back and we can create a dummy node. And that dummy node we can point back from 5 to, let's assume that this is the dummy node D. And then this is the small pointer. So all we need to do is that we need to compare the small pointer with the dummy pointer values, and then keep on going in the reverse order. And if both values remains the same, we can simply say that this is a palindrome. So how it would work is that, let me just clear this up a bit. And okay, so currently both at this location 5, we created a temporary node, that the temporary node points back towards 3. This is where our dummy node lies, and this is where our slow pointer lives. So dummy node dot next is going to be 3, and slow pointer dot next is also going to be 3. If both values are correct, we move to the next element. Once again, dummy node by dot next is going to be value number 2, and slow pointer dot next is also going to be value number 2. And same way, if we keep on iterating, eventually we would reach to the end of the list from this side and also end of the list from this side, and then we can determine that whether this is a palindrome or not. So this is the second approach. Now I know the second approach of using 2 pointers is actually an overkill. There are a lot of concerns, because the moment you would propose this solution, your interviewer is going to ask you that what if you cannot change the existing input. Then in this case, once this operation has been completed, you once again need to reverse the nodes to represent the linked list in the same fashion it was, that looks something like this. So there are a lot of overhead of operations in order to save in terms of space complexity. So both solutions are accepted and valid. The thing is, the stack solution has the space complexity of big O of n divided by 2, and the pointer solution that I just explained in the last, that contains the space complexity of big O of 1, but you are actually doing a lot of iterations back and forth, and you are also manipulating the given input string as well. So consider these two items, and now let's quickly see the coding solution. So in the code, I'm showing the solution for the 2-pointer approach, but if you want, I can also show you the coding solution for the stacks. So let me know in the comments if you want to see that. So here is the Java code for the solution we just explained. So first of all, we are going to check for the edge case, that if the given input is null, we can simply return true. If that is not the case, first we will try to find the middle of the linked list using the slow pointer and the fast pointer. Once we do that, now we are going to start reversing the second half of the list using the reverse function for slow.next. And then we are simply going to compare the first half with the second half. And once the comparison is done, we simply need to check at any given moment that if the moment we identify that the values are not matching with each other, we can simply return false. If that is not the case, we can simply return true if we at any given moment reaches to the end of the list. And this is the whole solution. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. Okay, so our code runs extremely fast compared to a lot of other solutions. Hello friends, we are not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do encode and decode strings LeetCode problem, and as you can see, this is actually a LeetCode premium problem. If we see some of the companies who have already asked this question where I want to get a job, there are companies like Facebook, LinkedIn, Google, Square, Uber, Microsoft and Apple. So all of my favorite companies have asked this question, so that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode medium problem, and basically we are given a list of strings. Now we need to design an algorithm where we are actually encoding this given list of strings into a single string. Then we are told that that single string is supposed to be sent over a network, and then when we get back to the second machine, we need to decode that given string into the original list of strings. So let's try to understand this with an example. So suppose we are given a string S where we are given bunch of different strings that looks like this. So after this, we will actually create an encoded string. Now this encoded string is combination of all of these four items, and it is just a single string. So let's say that this is the encoded string we have created. Now after creating this encoded string, we need to write a function to decode the string as well. And after we decode the string, we should get a response that exactly looks like this, and this would be the original decoded string we would get. And this is what we need to return. So we need to return the algorithm to encode the string and also an algorithm to decode the string. So let's see that what would be the different approaches we can take. Okay, suppose this is the original string we are given and we need to encode the string and decode the string. The idea is we are actually going to use an extra character, and where we are going to use an extra character, we would put it where one string ends before other string starts, and we will keep on repeating the same process, and all we have to do is, so that would be the way to encode the string. After encoding the string, when we have to decode, we will just simply take that character, and the moment we reach that particular character, we would know that okay, this is the place where one string ends, so we would create a new string for that, and then we will repeat the same process. So let's see that in action. So first of all, suppose we take this character that looks like this hash, right? I'm just taking any random character. The idea is you can discuss with your interviewer that what kind of character you can take. So suppose I take this hash. Now I do encoding string. So the encoded string is going to be AB. Then the moment I identify that this strings ends over here, I would put a hash and I would keep a continuous string. Now I realize that okay, this is a new string B, so I would add a value B. Again I would put a hash. Now again this value is C, again I would put a hash, and again at the end I would find this value A, B, C, and that would be the end of the string. So now I have created an encoded string. Now if I want to decode the string, the decoding would work like this. So first of all, I'm iterating until I find that this is a valid string. So valid string is AB. Now I realize that okay, this is the hash, and hash is the character that I put it as an extra character as an encoding mechanism. So I would remove this hash and I would treat this as a single string. Now I would again start creating a new string. So again I find this value B. The moment I encounter the string hash, I would treat this B to be a separate string. Again I would encounter this value C, and again I would encounter this value ABC, and this is the way we are going to encode and decode the string, and this solution would work as expected. If we see the time complexity, in this case the time complexity is actually going to be big O of n. Why? Because we will have to iterate over all the characters that are present inside this given string S to first of all encode and then decode. So overall it would be 2n, but we can generically write it to be big O of n. Now if we see the space complexity, in this case the space complexity is actually not that much, because we anyways will have to create an encoded string and decoded string, and all we are doing is just using an extra space to solve this problem. So this is pretty simple to me. Okay, suppose this is the string we are given, and the idea is we are actually going to add 4 bits that are going to store the length of any given substring, and then we are going to keep on repeating the same process, and we are going to create the encoded string. So let me quickly show you what I am suggesting. First of all, we would have an encoded string where first 4 character is actually going to store the information that what is the next length of substring that is coming that we are going to iterate over. So in this case, this is actually length 3. So if we add it in binary, represent as 0 1 1, so we are actually going to have 0 0 1 1 to be the length, and then we are going to store these 3 characters as A, B, C. Okay, now we are done with that. Again now this ends the first substring, so now this is of length 2, so length 2 becomes 0 1 0. Now we are going to do the same thing, and then we are going to store this value AB, and now this is also of length 2, so again we will repeat the same process. and we are going to store the value of x and y, and this is the encoded string. What we have done basically is we have actually created block of 4 bits that keeps the information that okay, in the next subsequent value these are the 3 characters that you will have to iterate over, and that is how we are going to decode it. So let's see the decoded string in action. In the decoded string, first of all we are going to iterate over this given encoded string. Now we iterate over these 4 characters and we find that okay, value is actually 3, which means that next 3 characters are the characters of one of the substrings that we will have to separate. So we will iterate over these 3 and put it in a substring, and we will get a substring like ABC. Again we will iterate over these 4 characters and we realize that the value is actually 2. So because 2, we will have to iterate over these 2 elements and we would get the value AB. Now again we would iterate over this next 4 bits and we find that value is actually 2 again. So we will iterate over 2 more characters and we will get the value XY, and then we would have a decoded string. So this is also another way to store all the values. Now this solution also works as expected, but I don't think that anyone is able to come up with this in the interview. So I just showed you this approach just for the explanation purposes, but actually I'm going to, in the coding, I'm going to show you the first approach that I solved earlier. So first of all, we are going to do the encode function. So let's take care of some edge cases first. If that is not the case, we are actually going to take a random variable that is not part of this original given string. So we are given the condition that there could be 256 characters inside the ASCII character for this given string I. So what we are going to do is we are going to take the 257th character as the character that is a separator between any two strings. So first of all, let's just create a string called a separate, and we are going to assign the character 257 to it. Now we will start building our string. Now we will iterate over this given list of strings. So first of all, we are going to append the value of whatever the string we are iterating over, and the moment this string ends, we are going to add the separate character. Once this loop ends, basically we should have done with encoding our string. Now all we have to do is just delete the last character because that would be an additional room. And once that is done, all we have to do is just simply return this new string builder we have created. So now we are done with encoding our string. Let's decode our string. If this given string S is actually of size whatever the located at 258, which means we are dealing with an empty string list. So in that case, we will simply return a new array list and we should be done. If that is not the case, which means that we have a separated string. So let's just assign a new character. All we have to do is just return an array list where we are going to separate based on this given separate character. And that's it. Let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our solution is actually pretty fast compared to a lot of other solutions. It's not most optimal because I did not choose the approach 2. And let me know if you want to see the code for approach 2 as well. Thank you. The title of this problem is called letter combination of a phone number, and now many of the iPhone users won't know it, but in the past phone actually did used to look like this, where if you have to type any messages, you will need to do it according to the keys that are present over here with the corresponding numbers. And people were so good that they were able to do it without even looking at it. But anyways, now coming back to the question, this is a LeetCode medium problem and also an extremely well-liked problem on LeetCode. Also has been asked at tons of popular companies. So let's see that what does the problem statement ask us to do. Basically, we are given a string containing digits from 2 to 9, because notice that in this problem, we are only given the characters from A to Z present between the letters 2 to 9. Now, inclusive. Now we need to return all the possible letter combinations based on the given digit numbers, and that it can be represented. For our convenience, we can return them in any order. So let's try to understand this with a couple of examples. Suppose we are given as an input just character number 4. So how many characters does this character number 4 can represent? Well, only 3 characters. So if we have to return this, the answer is going to be G, H and I as the answer that we need to return. But let's assume that instead of that, we are given the input as like 4 and 6. Then what should be the answer? So we know that 4 can represent G, H and I, and 6 can represent M, N and O. So the answer is going to be the combination of both of this GHI and MNO. So the answer would look something like, where you can see that currently we have 9 entries and they are combination of all the characters from these two entities, and that's what we need to return. So this is the whole problem statement. So let's try to see that what is the approach we can take to solve this problem. Now, number one thing is that currently we are only given characters between 2 to 9 as an input and nothing else. So first thing we need to do is that we will have to create a mapping so that based on any given input location, we can actually identify that if the character 2 is given, we know that it can only have the possibility of storing ABC. Same way, if character number 9 is given, then it only has the possibility to store 4 characters W, X, Y and Z. And same way we can store this in any such fashion so that this lookup needs to happen in big O of one time. So we actually have two options to do that. Number one option is that we can actually create a hash map, and inside the hash map we can store all the entities, and based on the key we can mark as the digits, and their subsequent values we can mark all of the entries. So that is option number one. This will yield in big O of one time complexity whenever we have to do the lookup. Second option is, since we know for sure that we are only dealing with characters between 2 to 9, nothing more, we can also create an array, and inside the array, based on the index positions, we can store the values. So let's assume that because in the array we have values like 0, 1 and then 2 and all, or so on and so forth. So for 0 and 1 we can store as an empty strings, because anyways they are not going to be part of our inputs, and starting from position number 2 we can start storing values as A, B, C and stuff like that. Now this is only for our convenience purposes, so that we can quickly look up what element we are trying to find. Now this is the pre-work that needs to be done in the solution so that we can do it in the efficient manner. Now let's see that what is going to be the optimal approach to solve this problem. Suppose as an input we are given the characters 2 and 3 that we need to return. Now we know that 2 is represented by ABC and 3 has been represented by DEF. That we actually take this given input 2 and 3, then we break this input based on all the digits it currently has. So first we get the digit 2. For digit 2, whatever the characters that it can represent, we create 3 decision trees based on that. So currently it can represent A, B and C. So we create 3 separate decision tree. And now, since this is not the answer, because we need to return the combination or the potential combinations that can be there. So this is just a part of the answer that we have created so far. But now we will have to complete the combination portion. So in order to do that, the number one thing we will need to do is to keep track that how many number of characters are currently present, or how many number of digits are present and how many are pending. So now 3 is pending. So we will append 3 with each of these decision trees, and we know that 3 is currently represented by these 3 values. So once again, for each one of them, we are going to have 3 separate decisions tree being made. Notice that currently at this very first location 2, we only had one entry per character inside our representation. But the thing is, in the input we were given 2, 3, 23, which means we were dealing with 2 character letter. But in the problem, we are only at half of the step, where we only have just 2, which means after creating this possibility, we still have to wait to add the values to the answer until we find this path where now the index position matches the total number of inputs that we are given. The moment this condition matches, we will need to add it to our answer list. So because over here we only had 1 characters, but now we had 2 characters, and even in the input we were dealing with 2 characters, we are going to add DA or AD in the answer. Same way AE is going to be part of the answer. Same way AF is going to be part of the answer. And the good thing about this is, because this is same operation being done multiple times. So we can actually keep on doing this. The moment we find out that this is one of the potential pair that we have already added to our answer, we can actually backtrack to see if A still has any more values that it needs to add to the answer. And yes, AE still needs to be added. So we will add AE. Once again, we will backtrack to A, and once again this AF needs to be added. So we will do that. Once again, we would backtrack to 2. Now we have completed all the path with A. So we will repeat the same process with B. And this is the whole answer we need to return. Now I know what I just explained might have confused you a bit. So that's why when we do go into the coding section, I will explain the whole thing in much more clarity. But this is the whole approach. Basically, we are simply using recursion and backtracking to solve this problem, because repeatedly we are doing the same operation. And we know that for this, we need to have an terminating case. So terminating case would be that the moment we identify that one path or one combination contains the same number of characters as the number of input that is given or the index values, then we need to add it to the answer and once again do the backtrack, keep on repeating the same process until we have exhausted all the possibility, and whatever the answer we found, we need to return that. Okay, so what is going to be the time and space complexity in this case? The time complexity is only going to be the number of potential combinations that can be made, which means the number of characters that are given. So let's assume that this currently has 3 times 3, 6 characters. So whatever the value is, so we need to do square of the number of given input for every single digit. So in total, it is going to be the number of combinations that are currently present. That is going to be the time complexity. For the space complexity, because we will have to create another array that contains all the mapping from the characters 2 to 9, we will have to store that, but that is going to be limited in scope. So instead of calling this as big O of n, we can actually treat it as big O of 1, because the space complexity is not going to change. So now let's see the coding solution. Okay, so first of all, we are going to initialize our string array, where we are going to mark first couple of entries as blank, and then we are going to mark all the values. So this is going to allow us to iterate over all the digits to the letters. And then let's start our code actually for the problem statement for this method letter combination, where we need to return a list of strings as the answer. So first we are going to initialize a combination string that we are going to return as the answer, and this is going to be the blank array list so far. Now first we are going to check for an edge case, that if the given number of digits is equal to null or digit.length is equal to 0, then we simply need to return combinations. If that is not the case, we are going to call our backtrack method, and we are number one thing, we are passing this list that we have created. We are also passing the input digits that we have received. We are passing an empty string that is going to be considered as the current combination that we have so far, and we are passing in 0 as the current index values that we have processed so far. Okay, now let's see this backtrack method. How does it work? So number one thing we are checking is that if this given current index location, if that is equal to the digit length, which means we have an answer that we need to add to our current combination. So we are going to add all the answer that we have found in the current combination to our combinations array list that we have created. If that is not the case, we are first of all going to differentiate the letters for every single index position. So let's say in the input we are given value number 2, then we would have ABC as the letters passed on, and then we are going to run a for loop across every single letter. But now this time we are recursively going to call back the method backtrack. We are passing in the same combination, same digits, but for the current combination, we have added the current combination plus the current letter we are working on. On top of it, we have also updated the number of increase value, index value. So if in the previous iteration, if we would have passed in value number 2, in the next iteration, we would have passed in value number 3. And that's how we will be able to start storing all the combinations in the current combination array string that we have created. And this is it. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs pretty efficiently compared to a lot of other solutions, which is awesome. By the way, you can always find this coding solution in the GitHub repository we have, and the link is in the description, so you can check it out from there. Thank you. So the LeetCode problem we are going to solve is called text justification. Now you can see that this is a LeetCode hard problem and also a very controversial problem because it has more dislikes compared to likes. But the thing is, the only reason I'm solving this problem is because this has been asked at tons of different companies. So let's try to understand the problem statement. Basically, we are given an array of string called words and we are also given a number called max width. Now we need to format the text such that each line exactly has the max width character and is fully justified from left to right. Now there are some conditions that we need to follow in order to complete this exercise. So we should pack our words in the greedy approach, that is pack as many words as you can in each line, and every single word or between two words we need to have at least one extra space when there is necessary. Also we need to make sure that every single line exactly has the max width characters. Now we are also being told that whenever we are dealing with extra space between the words, they should be distributed as evenly as possible. But in case we realize that the number of spaces on a line does not divide evenly, in that case we need to divide it between the words. And if there are empty slots on the left, we are going to be assigning more space on the characters on the left hand side. And the last condition is that for the last line of text, it should be left justified and there should not be any extra space inserted in between the words, and that's it. Now there are a bunch of different conditions, so let's try to understand this with some of the actual examples for this problem. Now we are given a string or string of words such as like this, where it says that this is an example of text justification, and we are being told that the maximum width in every single line we can have is 16 characters including the spaces, nothing more than that. So let's try to see that how does the solution for this problem should look like. Now the thing is, first let's see that how many characters this needs. This has 4 characters, then this has 2 characters, and then this also has 2 characters, and this example has 7 characters. So let's try to sum up, and we are trying to root for or find the greedy approach and trying to find as many words as possible within the boundary of 16 characters, plus we will have to consider at least one space between any single 2 words. Which means what I'm suggesting is that instead of treating this as like 4, 3 and 2 by its character size, we are actually going to add one more value to it. So let's assume that this is 5, then this is 3, this is also 3, and this is 8. Okay, so now let's try to do the sum and see how many characters can we fit in. So for this one, maximum is 16. Now if we do sum of these 3 characters, then we get the value as 11, and then 11 plus 8 if we try to do, it goes 19. So 19 actually exceeds the value we are trying to find, which means we cannot include this character example. Okay, so after realizing that we are only going to be working with these first 3 words, so we have this first word, that is this, second word is, and third word is n. Okay, and we need to put this in one line such that the first word starts with t inside this given line. The last word has to be n because we don't want to have extra space after the last character for this particular line. Okay, so this has to be first word, this has to be last word, and we need to have in total 16 characters. Now the thing is, originally we saw that we were considering 5 and then 3 and then 3 in terms of characters, but now let's not consider these spaces, let's only consider the values of the characters, which means this is currently 4 characters long, this is 2 characters long, and this is also 2 characters long, which means in total we are working with 4 plus 2 plus 2, so total 8 characters we already have, which means we will have to add 8 spaces inside this first line that we are trying to create, which means we can put 4 spaces over here and we can put 4 spaces over here, because remember there should not be any space after this character n. So in this case, we are going to build a string like this. So first is going to be this, then there are going to be 4 empty strings, then there is going to be character is, and then once again there are going to be 4 empty strings, and then we are going to have the character n. And this is going to be the first part of the answer, where we have created a string that contains exactly 16 characters, and we will still have to iterate over these remaining files. So let's try to repeat the same process once again. So let me just write down this answers at some place. Now let's try to find the second line, and let me also clean this up a bit. Now let's repeat the same process for the remaining characters. So how many number of characters this example has? It has 7, but we also need to consider space. So there are going to be 8 characters. This off is going to have 3 characters. This text is going to have 5 characters. And this justification is going to have 14 characters. And since this is the last character, we are not adding an extra space. And remember, there is also a dot or the full stop behind this line, that this is also considered as an extra character. So now let's try to do the sum. So if we do 8 plus 3, we get 11, 11 plus 5, we already get 16, which means we are by default at the 16 character mark, which means we cannot add this justification. So now let's try to deal with just these 3 words. And once again, we are dealing with example and then off and then text. But now we are not going to include spaces for now, because we will have to do that calculation. So now this is 7 characters, this is 2 characters, and this is 4 characters. So if we do the sum, we get the value 13, which means in total maximum width we need 16, which means we still have 3 extra spaces that we have to distribute. But the thing is, now this is not an even number of spaces, this is odd number of spaces. So we will have to divide. If we try to divide this by 2, we get like 1.5, but this is, we cannot divide 1.5 spaces. So we are going to divide 2 spaces between here, and then we are going to put 1 space here, because remember, there has to be at least 1 space. And also if we divide 3 by 2, we get like 2 options, 2 plus 1. So this is how we are going to distribute the spaces. So second answer is going to look like this, where it's going to be example, then we are going to have 2 spaces, then we are going to have off, then we are going to have 1 space, and then we are going to have text. So this is going to be the second line of the answer. So let's also mark this one as well. Okay, and now in the end, we are only dealing with just single word, or in the last line, and this word contains 14 characters. So we are going to have it justified completely on the left side of the portion. So the answer is going to be quite simple, that we are simply going to create an answer with justification, and whatever is the remaining value, or in order to make it 16, we are just going to add extra spaces, and this is going to be the answer. This is the total 3 strings that we will have to return, and this is the whole explanation of the problem. Now how to solve this problem? Well, actually I was also solving this problem along with explaining the problem, because we don't have to use any extra specific data structures, we don't have to use any extra characters, nothing like that. The simple logic is that we are simply going to run an algorithm. The purpose of this algorithm is that, let's assume that currently we are given the word string, and this are given like X number of words, okay, and each of them are in the different length. And let's assume that the width we are given is, for some example, 10. Now the logic is, first we are going to keep on iterating across every single word, plus adding a space with each word until the point where we run out of the number 10. The moment we run out of the number 10, we will have to identify that what was the last character that would not be included, or the last character that we can only include. So let's assume that we can only include up to this point in just one line, which means for the next line we can consider all the remaining items. Now amongst these lines, we are going to forget about this one space for now. We are only going to be concerned with the size of the characters and see that what is the size of the characters we get. So let's assume that we get the size of the characters as 6. So if the size of the characters is 6 for each one of them, which means we will have to deal with 4 extra spaces. So now in this case, if we are dealing with even number of extra spaces, so we can simply put it between these 2 words, or all the remaining portions between any number of words. And then we once again mark it as the part of the answer. So these 3 X are going to be part of the answer. So X, then 2 spaces, once again X, then 2 spaces, and then X. And then we are going to repeat the same process for this remaining item. So this is the whole solution. And in order to build the string, we need to use string builder class or some sort of that functionality. Every single language has the way in order to build the string. And this problem seems hard, but it is only hard because you will have to iterate over this logic, and there are a lot of different edge cases that we need to cover. What is the importance of this problem? Well, this is how actually the tools such as like Word and Google Doc, they actually do the text indentation. So that's why this problem has practical implication. There are no questions in that. But this specific problem does not deal with data structure as much as it deals with iterating over different strings and trying to find the reasons. And that's why this is such a highly unliked problem on LeetCode. but it is what it is. I just explain you that how to solve this problem. When we do see the coding solution, things will make much more sense. If we see time complexity, it's pretty simple that the time complexity is going to be big O of S, where S is the total number of characters that are present inside this word string. So sum of every single character. So first of all, we are going to initialize an array list called lines to store our answer. Then we are going to have an index value starting at 0, and we are going to have the condition that while index is less than the total words that dot length, we are going to first of all do the count of all the words, length of all the words, and then we are also going to keep track that what was the last value of that we have been able to identify, and we are going to put it as index plus 1. Then we are simply going to iterate over that while last is less than the current words dot length, we are simply going to keep on adding the value and keep on checking that if the next adding the next word exceeds the max width or not. If it exceeds the max width, we simply break. If it does not exceed, we increase our counter, and we also increase the last pointer as well. Now, once we are at this stage, we are at the position where we have the values of the words that can be included in one single string or one single line for the answer. So we are going to initialize a string builder. Now for this string builder, we are going to append the words that are currently present at the index. And then we are simply going to check that if we are on the last line of the line and it has only just one word, we are going to do a left justify, which means we are going to put all the words that are currently present, and whatever the difference is, we are simply going to append that for our existing string builder. If that is not the case, then we are going to calculate that how many spaces do we need to do. So we are going to calculate the spaces based on the maximum width minus the count divided by the difference of the number of words. And then we are going to check that what should be the extra spaces divided amongst each entity. So for that, we are actually using the modulo function by diff. And then we are simply going to run a couple of for loops in order to generate the string that I just explained. And then in the end, we are going to add all the strings that we have been able to create inside our string builder and return lines that we have initiated originally the array list as the answer. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. Our code runs 100% faster than all the other solutions, which is pretty awesome. And once again, I will be posting the solution in the GitHub repository. Link is in the description. Thank you.